What is up? Daniel back again with the Virtual Robotics Studio. And today's video is all about electrical, except before we get to the electrical, we actually have to make some stuff to attach the electrical to. So we're going to hopefully wire the whole robot, but we're going to need to attach our battery mount. So you should have gotten a battery mount kit in the kit of parts. We don't need all the pieces from it. We need this kind of U-shaped one with an extra tab on it. And we need, I guess this one is a face with 3 eyes. I don't know, we need this plate. And then from this bag, we're also looking for, there is a tiny little plate that we're going to use to hold stuff together. And then I don't have one with me right now, but there is a strap that we're going to use to strap the battery in and hold it in place. And then for hardware, we're looking for a 1032 by 1/2 inch long bolt and the 1032 nylock nuts. Those might be like shiny. We might have shiny silver ones. Doesn't matter as long as they're 1032s by 1/2 inch long. Then the other thing we're going to do is we're going to make a belly pan out of some 1/4 inch plywood. And when you get this plywood, get some of the nicer plywood. Don't buy the really cheap stuff because it's not going to, the ends kind of get bad and it's harder to attach stuff to. But we're going to make a belly pan out of this that's going to fit inside the robot, kind of in the front and back. And that's going to give us a nice surface, a nice shelf that we can attach all of our electronic components to. All right, let's move some of this stuff out of the way. We're going to start with the battery mount. But before we do, special thanks to Argosy and Everybot. Okay, first step for the battery mount is get this U piece. And this extra tab here is to actually connect. You can connect the battery connector on here so it stays in place for you. But this is going to go on top of, make sure you're on the back of the robot, so the side with the motor and the jack screw, not the side with the intake. And this is going to rest on top of our back C channel here. And what we want to do is we want to center it as much as possible. So like if I guess here, I've got from the bolt here, I've got 1, 2, 3, 4 holes. And from this side, I have 1, 2, 3, 4, 5 holes. So that's as good as we can get because we can't do 4.5 holes on each side. And all we're going to do is drop the bolt in from the top. And we'll use all 4 of these holes for it. And then from the bottom, we're going to have to reach up and start the nylock nut. And just a quick reminder, remember the nylock nut, we have the side where you can see the plastic. And then if we flip it over this side, you just see the metal. The metal should be up towards the frame, right? So the metal goes against the thing that you're attaching it to. So the bolt will go into the metal side first and then end up in the nylon side afterwards. All right, so we'll get that started as far as it'll go. And then this one. Okay, and then it takes a 3/8 wrench to hold the nut in place, and then a 5/32 hex key. And I have a handled one, which is nice, goes quickly. But if you just have the L-shaped one, no big deal. All right, and then we can drop the other 2 in. These are probably not necessary, but this is pretty low down on the robot, so adding weight down here is not a bad thing. And you don't want the battery to come loose. It's one of those things that it's just not worth taking a chance on. So we'll go ahead and tighten this other bolt in. And the last one. So that's in nice and secure. Let me flip this around a little bit now. And we're going to be working underneath this one now. So we're going to take the giant 3-eyed face plate. And this part is not going to get attached. So first of all, our channel is upside down on this robot compared to the official Andy Mark design. So we're going to be attaching things a little bit differently in order to make these plates still work. So normally, the side with 4 holes, we would come across, and we would attach those 4 holes onto the bottom of our frame in here. But if we do that now, there will not be room for the battery to fit inside here. So instead, we're going to turn this around. So this side has 2 holes, and they're a little bit bigger, which is not, it's OK. We're still going to use our number 10 bolts. You can see they still catch on those holes. So we should be all right. If yours looks like it's not catching, you might want to grab a washer. And if you put a washer on the bolt, that'll help spread it out a little bit more and still be able to grab. But this, we're going to slide in. And we need this to be on, there's two rows of holes down in here. And we want to aim not for the inside one, but the outside one. So as far back on the robot as we can. And we want to try to center this plate with the plate on top. Let me get this to drop in and we'll see how we look in. Okay, so that looks pretty centered to me. So I'll now reach under the whole robot and start this bolt going, or the nut going on the bottom. And just want to get it finger tight for now. And we should be able to get one in the other hole as well. We'll finger tighten that one. Remember, to get the Allen wrench to line up, you can go through the hole on the top of the frame. You just need to have a long enough hex key. All right, then let's look inside. We want to make sure that we're sort of centered with this plate. And you can kind of tell if this tab and this tab are both lined up, you're probably in a good spot. You can also count the holes. So 1, 2, 3, 4, 5 and a half. OK, I said we couldn't do half holes before, but apparently we can on this one. And from the other side, 1, 2, 3, 4 and a half. So we have 5 and a half, 4 and a half. That means we're going to match with our top plate so it's in the right spot. The other thing is this plate is loose because we have those 1/4-inch holes. So this plate can shift around a little bit. It's going to be a little bit tight for the battery to fit. So I want you to pull this away from the back rail towards the motors as much as possible. And that's the position we want to tighten it in, because that will give our battery the most space to fit. So once we've pulled it forward like that, we will drop in our hex key here and start tightening it. Again, I'll just make sure that stays forward. We'll tighten that one in and then do the other side. All right, I'll spin this back around now. So this is room, let me grab a battery and we'll look at how that goes in. So the battery will be able to drop into here, and you can test this with your battery as well. And it should be able to clear on the bottom as well. If it doesn't, mine is really tight. So what I'm going to do is, if I can get it out. Okay. So what I'm going to do now is I'm going to loosen up pretty much all of my bolts, because that is tighter than I want it to be. So let's reach down in here and loosen up the bolts on that bottom plate. Okay. And then I'm actually going to loosen up the bolts on the top plate as well. Just enough that the plates can shift. Okay. And now what I'm going to do is I'm going to drop the battery in while everything is loose. Okay? And that made it down now. It's sitting on my bottom plate. So this is basically the best position that we can do to attach everything. So now I will go back, and with the battery in there, it'll be a little bit harder to reach everything, but we're going to tighten it in now because we know it works in this position. And if you can't get the inside bolt, looks like I can do it. If you can't get the inside bolt, as long as we get the outside two tightened, you could do the inside two after we take the battery out. All right, and I'm not sure how these batteries come anymore, but I have the bare contacts here, so you got to be really, really careful that metal stuff stays away from the contacts. You don't want to short those out while you're working. But I'm guessing a brand new battery will have something covering those. All right, let's tighten the other ones on our lower plate here. There's one, and there's the other one. All right, now everything is tight. If we can take the battery out, we're in a good spot. And we can. Okay, so now all of our plates are mounted where we need them to be mounted. We have one more piece that we can attach, and that is, I don't have the actual strap that came with the kit yet. It is on the way, but I'll use this piece of Velcro because it's going to work basically the same way. And we're going to take this plate, and we're going to line it up in between these two sides as evenly as possible. So that's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's perfect. And the idea is we're going to put this strap underneath it, and then we're going to tighten bolts down, and that's going to hold this strap in place. Okay, so it's going to be the same bolts. And I think we just need one bolt in each end hole here, and that should be good enough. So let's get them started. So just make sure you're clear through on the other side, and then you can go ahead and tighten these down all the way. All right, and you can give this a little tug, and it should be pretty securely in there. And the idea is the battery will go in, okay? And then once the battery is in, I'll take it out just so we can see what's going on the other side. I think the straps that come with it should be able to go down through this hole, and they should be able to go back up through the other hole. Or you might have to go around the outside, and this will also help hold your connector together. And then you basically will pull this tight and connect it on, and that'll hold the battery from moving up and down. And the battery can't move forward, backwards, left, right because it's jammed in here. And it turns out, like up, you don't need as much strength to hold it up and down or to stop it from moving up because you also have the gravity of the battery keeping it down. So a Velcro strap is actually more than strong enough as long as you are secured on the other 1, 2, 3, 4, and the bottom 5 sides. All right, so this is looking good. Our next step then is to, well, we'll get rid of the battery, and we will start measuring and cutting out our wood belly pan. Okay, so time to work on the belly pan. And it's going to come in 2 different sections, actually. The easiest way to attach it is there are these inside rails in here that we can connect, or we basically can lay it down on and then connect to it. So we've got kind of this one running along the edge here, runs all the way back, and then we have the same one on the front of the other side of the robot. But turns out the motor transmissions are actually hanging down low enough that we can't have just one piece that fits all the way across. And even if we did make it one piece that fit all the way across, we would have to take the motors out, put the piece in, and then attach it, and then put the motors back in, which is more trouble than it's worth. So we're going to make one that fits on the back here. And it looks like, I think the instructions say we're going to go 5 1/4 inches. So you can kind of see 5 1/4 inches should fit in here relatively nicely. Looks like we do have to watch out for this bolt that's down here, the bolt that we put into our churro. That could crash into the wood, so we're probably going to have to cut a little notch out to clear that. Then on the other side, we're going to go all the way up to 11 inches, which looks good. And on this side, we have these bolts that we use to connect in the corner here. So those ones are going to have to be notched out for. And then we have the same churro bolts over here on the other side that we're going to have to cut a little notch out for. Just to kind of clear stuff. Or maybe not. Maybe we'll clear those. But that is basically what we're looking at. And then if we look at the across the robot, I am getting 13, maybe 13 1/8. So we're going to make these pieces 13 inches wide. All right, let's slide the robot kind of out of the way here. Not so far that it falls. And let's bring up my plywood. Okay. And there are lots of different shapes of plywood that you can get. If you got a 2 foot by 2 foot piece of plywood, that would be big enough to fit everything. I think when we went to the store, they only had a 2 foot by 4 foot piece. So that is what we're going to be using. So our first piece, we can mark it off. So let's see. just double check. Yeah, we are 24 inches wide. Both of our pieces are 13 inches wide. So we want to create a 13-inch section of stuff. And then one of them is 11 inches. So if we went to 11 inches, and the other is 5 1/4. So I think the easiest way for us to do this off this 2-foot piece is to cut. We're going to cut a section that's 13 inches. And then we'll make 2 more cuts to get down to the panel sizes that we want. So let's get this up and mark our 13-inch line. All right, so 13 is right about here. And this 13, I'm happy to cut it a little bit longer than 13. I don't have to be super precise, but it can be up to 1/8, maybe even 1/4 inch long. And it can be a little bit shorter as well. All right, so we've got our lines. You can see they are definitely blurry. Pencil would probably have been a better marking item for this wood, but we're going to be okay. All right, so now we'll do the line all the way across. And essentially, this time, a lot of times I'll say we want to cut so the line disappears. This time I think we want to cut so the line stays on the board. We want to cut right up next to the line. Okay, and to cut this, 13 inches is bigger than our bandsaw. So yeah, this is going to be, if you have a circular saw, that's going to probably be a really good item to make this cut with. That's what I'm going to use. If you don't have a circular saw, if you have any other power saw that you can cut through it with, that's going to work fine. If you don't, you're going to need to grab a handsaw and take your time with it. All right, let me get this clamped down on the table so it doesn't move while we're cutting. And also make sure the line is off the edge of the table so that we don't cut the table too. We'll see, these 2 clamps, that feels pretty good. All right, so I'm going to grab my circular saw. And a battery here. Okay, and all we have to do is we're just going to cut all the way through until we get our clean 13-inch wide piece. Okay, 1 cut down. And I might have wanted to swap out for a finer saw. We kind of did a little bit of a mess, made a little bit of a mess here, but that's okay. Set this piece off on the side. Okay, then off of this, we are looking to make a 5 1/4 inch section, and then an 11-inch section. So let's go ahead and do the longer one first. So we're going to try to make this 11 long, and this can be a little bit longer than 11, a little bit shorter than 11. It's going to be fine. It is not a precise thing at all. So do 11 right there. And that is our next cut. Bring these clamps back. and let's go ahead and check this piece, make sure we did what we wanted to do. So that is 11 across, and it is just over 13 long, which we said was totally fine. So we're 13 and maybe a 32nd of an inch. Okay, perfect. So that one is done. Now let's do our 5 1/4 one. Okay, so this is the direction, yep. You do want to make sure that you're measuring this from the right side. So remember, this way is 13, so we need to be cutting on the other way. So this way is just under 13, it's very close. So this piece almost looks square. Make sure you measure. Find the side that is not 13. So this one's 13 and a little bit. This side is under 13, so I'm going to draw the line this way to keep my 13-inch width. All right, and this will be 5 1/4, so right there. And one more time, let's clamp this up and make our cut. All right, double check this piece. 5 and, looks like I'm just under 5 1/4, so missed that one by a tiny bit. That's going to be okay. And we've got our just over 13 long. So these are the two pieces we want to use. This one is our scrap. We could make another 5 1/4 if we miss by a lot out of this. So that would be nice. But we've got one more issue that we're going to deal with before we're ready to start putting these in the robot, and that is all of these edges. I don't want all of the splinters and stuff there. So if you have a sander, now's a good time to get out your sander. If you don't have a sander, you can just get some sandpaper and do it by hand. It's not that bad. And they make these like foam blocks that are pretty cheap that you can put sandpaper on. And I like using those as well. But I've got a sander here. Oh, I left the battery at the tip. I was thinking ahead. All right. So I'm just going to go ahead and sand the edges of these pieces so that there are no more splinters. All right, we've got our two belly pan pieces ready to go. We're going to attach them to the robot, but let me get rid of some of this sawdust first. All right, let's get these attached inside of our robot frame here. I'm going to choose the pretty side and make the pretty side face up. Let's see, if we drop this one in. So right now, I'm just checking to see if we need to notch anything off on this piece. And I think what we can see is right now, it doesn't hit any of the bolts. Like we can go underneath the churro bolts. We can move it back. We got all kinds of space in here. So this one I think is okay for us to not make any cutouts. But if yours is hitting and you're like running into maybe this bolt on the side here, or this bolt here is too big, then what you can do is you can come in on this plate and just chop the corner off on a diagonal, or do a little cut in from both sides so you get a little like square cut out of the corner. But I don't think we need to do that on this one, so we're not going to. let's check our other one and see if we need to remove some material for that one. So on the other side of our robot here, this one, I think we're going to have to do some stuff because it won't even go in. Okay. Can we go in this way? No. What if we go from the bottom? Does that help at all? I'm feeling like this is going to be a no, but doesn't hurt to try. No, we're just running out of room. All right, so we're going to have to do a bunch of cutting out on this piece. So when we try to drop this in, we are hitting this first piece here, which is this bolt. Then, as we slide down farther, we're going to hit this bolt. And then at the very end, these nuts that are sticking up here holding our frame together are going to be in the way. So we can probably measure them and do it. You can also sort of try to mark it where the issue is. So I'm going to do both, and then we should be able to get it to work out right. So I know there's an issue here. And then on the bottom, it looks like we have an issue until about here. And the middle one, I can't see at all. So that one we're going to have to measure. So measuring from the very front panel here, if I measure back from that front panel, looks like we need about 2 inches. If we can remove about 2 inches off the front of our piece, then we'll clear that. So let me see. I'll flip this over. So over here, we need some mark that's 2 inches in. Let's go ahead and actually use the ruler instead of, just writing it somewhere. So we want to be about 2 inches in. That's the first place. And then in order to clear them, how deep does that have to be? It looks like maybe 0.5 of an inch. I'm going to do 3/4 because it looks a little close at 0.5. So then we're going to do another line this way at 3/4 of an inch. And that is the rectangle we need to cut out. So I'm going to use my smaller square to lay this out here. And there's actually, well, let's see. I got to get a little bit more space. All right. I need to drop it off the table so that the square can fit. And we'll line this up and continue that line. And then we'll come this way. We can double check that we're at 3/4. That looks like a good 3/4. And then we're going to come in from this side and continue this line. And that is basically what we have to remove on that side. Let's turn it over. They're going to be the same on both sides, so this side is going to need the same thing. So we're going to go at 3/4. And then from this way, we know we need to go 2 inches. There's 2 inches. And then we'll just finish that out. All right, so that's 2 cuts we have to make. Then, I guess we're going to measure to the next problem. And the next problem is this bolt right here. Okay, and it looks like the bolt starts at about 5 inches, but we need a little bit more clearance than that. And it looks like it ends at about 5.5. So let's go from 4 3/4 to 5 3/4. That should give us 1/4 of an inch-ish on both sides. So 4 3/4 to 5 3/4. And that is from this edge, right? Because this is actually in there like this. And so we're going to do 4 3/4 right here. And we're going to go all the way up until 5 3/4 right here. So that looks like what we need to take out for that piece. That piece is very, very short, though. Looks like for that cutout, Probably half an inch is more than enough. So that's what we'll do. Take the square here, we're going to mark half an inch up. And on this side, we're going to mark half an inch up. And that is our vertical lines. And then we're just going to connect them. All right, so this section, so this is gone. We need to get rid of this. We need to get rid of this. We need to get rid of this. All right, same thing on this side then. And again, that was 4 3/4 of an inch to 5 3/4 of an inch. Okay, so we'll go over here. I'm going to go by the edge of the piece, and we'll mark at 4 3/4 and 5 3/4. And we're going a half inch in. So we will draw a line from the half inch out. And then we just need to connect the lines. And for any of these, if you cut a little bit too much, that's okay. If you cut a little bit too little, that's kind of okay too, because you can always come back and file or sand it to remove more of the material. All right, that is 2 of our problems. And now we had our third problem, which was all the way back at the end of the piece here. Let's measure to that one. So we've got this bolt up here that's stopping us from being able to put it in. And I have got, come on, tape measure, bend the way I want you to. There we go. So that one looks like it's 10 inches. Let's see, 9 7/8 to 10 1/4. 9 7/8 to 10 1/4. So if I measure out from this way, 9 7/8 to 10 1/4. You know, at this point, maybe we just notch the whole end. That's a pretty big cutout, but that seems okay. So 9 7/8. Let's go from 9 5/8. So we have some plenty of clearance here. So 9 5/8. And then, yeah, 10 1/4. You know what? It's not worth it to have, like if we cut it right where I said, we're going to have a little tiny tab at the end. And I don't think that helps us. So we're going to go all the way to the end of the piece. And then our question is, how much does this one have to stick in? And I can tell just from looking, half inch is going to be plenty. So we're going to, again, do a half inch in. So up to the half inch. And we're just going to connect that all the way out to the end of the piece. All right, and then we'll do the same thing at on the other side. Let's double check. That was 9 5/8 is what we did. So on this side, we're going to go 9 5/8. 9 5/8. Something. What did I do? I did 8 5/8. Hold on. Did I mark it wrong or did I measure it wrong? It's definitely 9 5/8. Okay. Let's fix this one. So to the number 9 and then up to the number 5/8. That is where this line should be. All right, that looks better. Okay, so this is the area that goes away, and my misdrawn thing stays. Then on this side, we do again to 9 5/8. 9 5/8. I'm looking from this side, and I think I'm seeing 9 and then going the wrong way. All right, 9 5/8. And that line is going to be a half inch in, so I'll start at 1/2 here. And then we will just connect it to the corner. Okay, and this goes away. That looks like we at least did it the same on both sides. And before I cut anything, I'm just going to kind of lay this in one more time. And I'm just going to kind of like peek from the bottom and the sides and see, does it look like it's going to clear the things that we need to have it clear? And I think it looks good. I think we're there. So now we have to make some cuts on this. And I think the easiest way to cut this out, if you have a bandsaw, vertical bandsaw, I think that's the easiest way. If you have to do it with a circular saw, you can cut in and stop, cut in and stop. If you go a little too far, it's not going to hurt anything. Or if you have a jigsaw or something like that, it's going to work well too. But I'm going to use our bandsaw because we've got it here. All right, we got our plate, we've got our bandsaw. I'm going to lower the guard down because we're cutting something very small, so stay safe here. And the end cuts are going to be easy. I'm just going to cut in, turn the piece, and cut in, although I'll have to flip the board over when I make that second cut. We'll cut in, turn the piece, and cut in. But the middle ones we're going to have to get a little fancy with. So let's cut the end ones first and then see where that leaves us. I guess we'll go ahead and, can we finish that one? Nope. So I got to flip it over. You can remark. You can remark this on the other side. You can do a straight line there. I think like for what we're doing, I can just freehand eyeball it straight enough, so that's what I'm going to do. All right, one corner is gone. Let's get this corner going. All right, and this one I will throw a line on because it's a little bit of a longer cut. So I'm just going to bring my line or bring my square in line with that cut I just made. Let me actually flip this over. Just come right out to the edge here, and there we go. And remember, this is all just to clear the bolt head, so if it's a little bit more, a little bit less, it's all good. All right, other side. I think I might be able to fit here because we have the other notch missing. Perfect. And then this one. That one's not going to reach, so let's throw another line on here. We're just going to go across like that. All right, and now we have to do these notches. And the way to do the notches is I'm going to cut straight in, and then I'm going to kind of cut diagonally back and forth until I can get down to the very edge. All right, a little rough, but it's gonna work. All right, let's see if it fits. All right, let's see if it fits inside here. So again, we have the big notch that's cut out that we want to be able to drop inside on where those, basically against the front of the robot. And then, as we lower this down, we can already see we're clearing this one, which is great. Maybe I cut more than I needed to, that's fine. And then as we keep going down, we can see we're now clearing this one. There we go. You can see we're going to clear this bolt down here, and it is now sitting flat on the bottom of our robot. So our next step then is to clamp these both in place, and once they're clamped in place, then we're going to drill and we're going to add some bolts through the holes that already exist on our frame. So let's see where we can sneak these clamps in. I'm going to actually take this one out just so we're just working on one at a time. And let's see, where can I add this clamp? I want to try to get right on the edge here, as much as possible. All right, let me go up one size. See if we can reach past that slot. Also, for some added fun, the motor is magnetic, so it's grabbing onto my clamp. All right, that looks like it's holding that side in well enough. Nope, it's not. All right, let's try again. But instead of having the clamp going up, I'm going to try to have the clamp go down, which means the best way to do that is actually if you roll this, let's see if we can go off the edge of the table here. We can go just off the, that seems scary. All right, we're going to do this another way. Off the edge of the table seems scary, but what we can do is we can take the whole robot and we can tip it down onto one of its sides. And this actually is something that we used to do a lot when we were working on our robots. So the question is, which side do we want to put it on? If we put it on this side, we'll kind of be resting on the chain and the sprockets, so that's maybe not quite as good. I think if I tip it onto the back, everything is strong structural stuff, and this should be able to move forward instead of taking any damage. So let's try to just tip the whole robot back here. And if we're careful, we should be good. All right, let's try these clamps because they have a much wider area that they're going to grab. And so I should be able to get in there and have something that it'll hold on to. There we go. So that's pretty good. We'll do the same thing on this side. If we can. How did that one fit in? There we go. So that is in there securely. Again, we're drilling through a little bit of wood. It's not going to fight you like aluminum will. So if you have to have one person kind of holding on to this while we drill some of the holes, that would be okay. What we're looking to do now is we're looking to add some holes kind of on the edges of the piece. So this hole and this hole both like have plenty of wood around it for me. So I'm going to start with those holes. I'll drill into one of them. And it looks like I'm still going to have to kind of push from the top. Just make sure you're not behind where the drill's going to pop out. Okay. We have one hole there. And you basically have choices here. With these half-inch bolts, they are not going to stick down too far. But if your bolts are any longer than this, so for example, if I put this half-inch bolt in, let me see. Sometimes with wood, you got to like give it a extra couple because the wood will kind of close back up with some of the splinters and stuff. All right, so if I put this half-inch one through, you can see it's just barely going to have enough for the nut on it. So that's OK. But if your bolt is any longer and you try to go in this direction, we're going to have stuff hanging down on the front and back of our frame. And that stuff could get stuck like when you're trying to drive up on the ramp at the end or the charge station. So we cannot have bolts sticking down past kind of like where these bolt heads already are. So because of that, I think it's probably slightly smarter for us to put the bolt in from this side and put the nut on the other side. So let me get the nut started over here. And I will just go ahead and tighten this down. Once again, this is sort of like when we were talking about plastic. We can make this tight, but don't really crank down on it because it will be stronger than the wood and it will crush the wood. All right, so we have one in up here. Let's go across to the other top one here and drill that one. And once again, we'll send the bolt in from the bottom. Oops, fell off. That seems good. And then, remember we have the notches down here? So I think this hole is the next kind of hole I can get to. So we'll go ahead and drill that one out. So just look where your notch ends and go to the lowest hole that you can go to. And we'll do one more over here. And let's get these clamps out now. All right, looks good. Good, and you can kind of push on this and see that with just those 4 bolts, that's feeling very, very sturdy. You could put some on the top here and pull that top section in. And maybe we want to do that. You'll notice, though, that these sides are a little bit different height than this back channel. So there is a little bit of a gap here. So if we add a bolt in there, it'll kind of pull it down. And I don't think that's, I don't think that's a big deal. And it will keep it from kind of shifting quite as much on us. So maybe let's go ahead and do that. And I'll probably just do one kind of in the middle here. And on this one, you may need a slightly longer bolt. I think if we can get it started, then the plate is going to bend for us. But if you can't get it started, just go ahead and grab a longer 1032 bolt, and it'll be just fine. Looks like I got mine going, so we'll be able to tighten this down. Good. And now you can see that we don't really bow at all anymore. We got that extra point where it's touching. All right, so our top plate is in. Our top belly pan is in. Good to go. Let's get the other one out. And this one, if you remember, is going to go somewhere in this neighborhood. And this one, I think you may need to cut some of those notches in, but I think like I can kind of come in on this angle and rotate it up and in. But if you need to cut the notches, it's the same process that we just did. And I think we're going to put this, guess what I'm going to do is I'm going to do it even with the end of this rail here. That seems like a good spot for it. So we'll go ahead and throw a couple of clamps on there. And we don't have the notches to deal with, so these clamps should be much less of a problem for us. Should be. All right, that went on good. And then we'll go on this side the same way. Okay, and once again, you can try to get some more clamps down here, and that would be fine. But right now, I'm having to put the clamps facing the direction I'm drilling, and I don't have any more small clamps. And again, because this is just wood, right, I'm going to be able to just kind of hold in on this while I drill through. Another thing is, before you drill, make sure you are on top of this plate a little bit, because this plate is going to add extra support to our piece of wood that's going across the frame here. So pull this one in, and we'll drill through. And we'll get it bolted in place. Okay, and try to just sneak this one. We'll see. All right, we'll just remove it. And so same thing, when you push on this, it's going to try to drill or push it out a little bit. So I'll hold on it. And that looks good. And one more over here. Okay, so I'm running into a problem on this one. Don't know why this one is giving me a problem and that one wasn't, but what's happening is the nut is hitting, remember this churro has a big bolt attached to it here, and my nut is hitting that bolt, so I can't actually fit everything there. So let's just move down a hole. No big deal. And we'll attach it there instead. Okay, that is both of the belly pans attached. There's something I noticed, though, while we were doing this drilling, and that is, if I kind of move the robot here, let me tip the robot back up, maybe. All right. Look at everything that fell out on the table here. So this all fell out from the inside of the robot. And we've only been drilling wood right now, right? So all of these metal shavings are from previous steps. And before we put the electronics in the robot, we really don't want any metal shavings. So putting the robot on its side was nice. That made some stuff fall out. I'm actually going to go ahead and I'm going to vacuum out the robot as much as possible and make sure that there's nothing left inside. And when everything's clean, then we'll come back and start putting our electrical components in. All right, so I have, I think, all of the electronic components that we have to fit on the robot. First thing is main power switch. This is actually a 120 amp breaker. And then we've got 4 SparkMax controllers. Those came in the kit of parts, I believe. Then, if you have extra SparkMaxes, you can use 6 of them. If you don't have extra SparkMaxes, the cheapest option to get another motor controller is the Victor. Right here, this is the Victor SPX, I believe. So we've got 2 of those that we will use. Out of there. All right, and then we also need from Rev, this is the radio power module. So this is going to end up powering our radio. And you may have, instead, this is the old version of it. So if you have one of these PoE injectors, we call it, it sends power through the Ethernet cable. Then you could use that instead. But this is the newest one, so that's what we're going to be working with on this robot. This one is not needed. All right, speaking of radio, it's basically just a wireless bridge, but this is the radio that will let the robot communicate with the, your controllers on the other side. Okay, let's open up these SparkMax boxes too. And inside the SparkMax boxes, there's a few things that we can do right off the bat. They all have this little plug. And this plug will fit underneath where it says A, B, and C, and above where it says Rev Robotics. You can kind of push that plug in. And it only fits one way, so if it doesn't go, flip it around and try again. And then if it still doesn't go, like a USB cable, you flip it around, and the first direction works. All right, and that idea with this is we're not going to use those pins, so by covering them up, it means that any aluminum or metal can't get in there and short it out and cause problems. Then from this box, we are also going to need the green cable, and we can plug that in as well. If you look on the side that says V plus and V minus, there is a port that says CAN and then /PWM, and then next to it is just a USB-C port. So we're going to plug in, on this cable, there are the 2 black connectors that have 2 pins or 2 holes on them. And then on this side, we have a 4-pin section. That's sort of a different kind of connector. That connector will plug in here. And there is a little raised bump on this as well, so this is only going to fit one way. So that bump is going to be facing down towards the black wire. Just go ahead and plug that in. You do have to kind of push on it right at the connector to make sure it goes all the way in. Okay, and you want to be careful when unplugging this. You don't want to grab it by the wires and unplug it. You really probably want to get a little screwdriver and see if you can get it to pry out from down there. All right, then also, so we don't need the USB-C cable right now. We don't need the white and black wire right now. We do need this white connector here, and that is going to end up, once we plug 2 of these wires together, and not these 2, because we're going to connect each of the SparkMaxes to the next SparkMax. You can actually use this connector to snap over the top of them. and that will stop them from unplugging. So we're going to end up needing that as well. So keep track of those. We don't want to lose them. All right, and I'm going to do the same thing now for all 4 of the Spark Maxes. I'm going to get the white piece, plug in the cable, and plug in the cover. All right, let's keep going. Next up is the power distribution hub. Okay, so we've got the hub, some stickers it looks like, and a bag of fuses. And really quickly, just going over the hub, these 2 big ones on the bottom, this is where we're going to plug in our battery power. And that is how you use these. You just kind of lift these up and push them down. We can use any of these other ports in order to power our motors. Then we're going to use the yellow and green wires here. Those are called CAN wires, which stands for Control Area Network. We're going to use those basically to communicate between all of these devices so that we can have our program be able to turn the right motors on at the right time. All right, and next to that, on this section, is where we're going to be able to plug in power. So this is going to give us 12-volt power, which we can use to power the radio, and we'll be able to use to power our main computer. But we need to put fuses into 2 of these ports, so 20, 21, and 22. I believe we can use any 2 of them. But go ahead and open up your fuse bag, and we're looking for the 2 red fuses. So they have something written on top. The red fuses are 10 amp, and the blue fuses are 15 amps. Basically, the main computer and the other thing that we're going to plug into this is the radio power module. Don't take a lot of power, so 10 amps is more than enough. And in fact, in the rules, you have to use a 10 amp fuse there. So I'm going to go ahead and go into 20. And you want to just get the metal blades of the fuse to go inside. If you look inside of here, there are little slots. And you just got to line it up so the blades go into those slots, because you could go next to it and try to force it in. But you want to be inside the metal slots, and it helps to kind of wiggle it, but you really want to make sure that is pressed in all the way. So we got one in 20. I'll do another one in 21. And these fuses, it doesn't matter if I plug it in this way or this way. The direction does not matter. All right, wiggle that one in. Make sure it's all the way in. OK, so this is the Rev power distribution hub. If you have an older kit of parts, you may have the one from Cross the Road Electronics. So this was the power distribution panel right here. This one comes with the fuses already in it, so you don't have to do anything with that. We've still got our CAN connections over here. We have all of our main power things. The one big difference is the main power actually gets screwed in instead of using those locking connectors, the tab connectors. So we'll point that out again when we get to actually wiring that up. But also, if you're using this, it doesn't have the regulated 12 volts built in. So you would also have one of these voltage regulation modules, which we would wire up from the bottom here. And then this would give us 12 volts uninterrupted that will keep our radio powered and not resetting during a match, which would be bad. OK, we'll set these off to the side, because we're not going to use these on our robot. And then finally, the last big box from NI, National Instruments. This is our roboRio. This is a roboRio 2, which I believe is what you will get in your kit of parts, or have gotten in your kit of parts. And this is basically the computer on our robot. So this is going to be plugged in to the radio from the Ethernet port here. Also, we're going to get power in this input section over here. And then there's room for us to plug in PWM devices. We can plug in digital devices, input, output. We can do relays. We can do analog in. And then we can connect some fancier sensors in this big middle port. But for us, mostly we're going to be using this USB hub here, the square one. We're going to be using the Ethernet port. We're going to be using the power. And we're going to be using the CAN wires. All right, so all of these things have to fit in here on our belly pans. So just to make a little bit more space, let me get rid of all these boxes, and then we'll come back and start laying stuff out. All right, we're cleaned up. We just have the devices we need. Let's figure out where to place them in the robot. So first, on the back side of the robot, our battery is going to be back here. And we want to minimize the distance that the wires have to go. So we got big 6-gauge wires from the battery. They're kind of heavy, but also the longer those wires are, the more resistance is in the wire, and the more sort of power we're going to lose to the whole robot system. So we want to keep those wires as short as possible. So if battery's back here, our main power switch needs to go somewhere back here, and our hub, our power distribution hub, also probably needs to go somewhere back here. And so we're going to try to just mount both of those onto our board in the back. Something like this looks pretty good. We can play around with what angle or where we want to specifically place stuff in a second before we attach it. But what I want to do is I want to put everything in the robot somewhere so we know that it all fits, and then we can go through and start attaching them one by one. All right, then on the other side, let's start with the biggest thing, which is our roboRio. So I think the roboRio, let's go in there, flashcard. All right, the roboRio, really? There we go. All right, the roboRio can go somewhere. Let's see, what do we need to get to on the roboRio? We want to be able to see these lights because we can, from those lights, tell if there are issues. Those are kind of like status lights. We want to be able to press the reset button if necessary. And then we're going to plug in a robot signal light over here. And then other than that, we just need to get to our power. This power is going to go all the way to this side of our robot. The CAN wire is going to go to our other controllers. And then the Ethernet port is going to go to our PoE injector, or our radio power module. So let's get that next, the radio power module. And one side, it actually says NI roboRio. So the roboRio is going to plug in on one side, and the radio is going to plug in on the other side. So this mounting maybe somewhere here would be good. So we can do our wire up from here into there. It can go out from there and then plug into our radio over here. Something like that looks like a pretty good start. Looks like we can we have lots of room for this over here. All right, then we've got our 6 motor controllers. And the good news is 2 of them are going to go somewhere else. So 2 of them are going to power we've got our Neo motor here that is powering the jack shaft and the main arm. And then on the gripper, or on the intake, sorry, we have this motor over here, which was our Neo 550. And what we want to do is we want to put the controller close to where the motor is. So this one is probably going to go here, so it can work with this one. This one is probably going to go up here somewhere, probably on top, but somewhere up there. We'll figure that out in a minute. So we can ignore 2 of these for now. We don't have to make 2 of them fit. We just have to make the other 4 fit. And I believe right now the plan is to have 1 SparkMax and 1 Victor powering each side of the drive. So this would be the 2 left motors, and then this would be the 2 right motors. So when we mount them in the robot, it doesn't really matter. We could mount them in any order we want, but I like to keep the functions clustered together. So I know these will be lefts and these will be rights. So let's grab these and go back into our space up here. And we've got a few. We could maybe attach them going across like this. We could do them going sideways like this. I think I'm going to attach them. It doesn't really matter which direction we attach them, but I think there's a little bit more room if they're going sideways. And let's see. So the side that is white and green, or the side that is red, black, and white, not just red and black, these are the sides that go to our motors. So you can see M minus and M plus, and then on this one, we just know it's motor minus and plus. And then this third wire is if we're using a brushless motor. We need an extra wire for that. So these are going to go towards the motors, which the wires are in the middle of the robot here. And then these other power wires are going to have to go from here all the way across the robot and plug into our power distribution hub over here. So I think I kind of like having the motor sides facing the middle, and we'll have the power sides facing the outside. So I think I kind of like something like this. And I'll put them maybe in pairs so they're next to each other. So I'll know we have the 2 left ones and then the 2 right ones, as it were. All right, so everything seems to fit. Everything seems to fit fine. So let's go ahead and start attaching them. There are multiple ways that you can attach these into the robot. The most secure way is everything has holes, so we could drill through and we could bolt the stuff in place. The speed controllers do not have holes, so we're going to mount them. I think these have little notches for zip ties to go around them. And the same thing here. They have these notches on the sides for zip ties, but these actually do have holes that go through as well. So doing a bolt all the way through the wooden board and bolting them in place is going to be the most secure. We're going to not do that too much because, I don't have the specific bolts that you might need. And there's another way that I think is going to be more or less just as good. Now, there are a couple of exceptions to that. Sometimes for the big power distribution hub, it's heavy. So you can think about that as it has a lot of inertia. If you crash your robot into something, that hub is going to have more force trying to slide it. So it's going to need a little bit stronger something holding it down. And a lot of times, just because this has big, heavy wires coming out of it, a lot of times I will also like to bolt the power switch down. But we'll start without any bolts. We are going to, in fact, start with Velcro. So let me get some Velcro and some zip ties, and then we might need to drill some holes in order to make the zip ties fit. All right, one last thing on this power distribution hub here is we want to be able to use some of these ports, but we don't have to use all of them. But it's nice if we can reach and use the ports on this side, because that's the direction the wires are coming in from. So we could do a test really quick. Could I get a wire into there the way that it is now? That looks a little rough, actually, to do that, even if the wire is coming up from the bottom. So what I think we're going to do, just to make stuff easy to get to, and you can adjust yours as well. Maybe if this slid over farther, we could use that side a little bit better. But based on where we put the board, I think I'm going to mount this towards the middle of the board and plan on maybe using some of these in the middle here. We can probably use the first couple. And then if we have to, we'll go to the other side of the board to plug stuff in. OK, so we're going to go through now, and we'll Velcro everything in place. Then once it's in place, we can actually just drill right through what's there in order to transfer the holes through the board if we need to do more. So I've got some industrial strength. I don't know. Just get some Velcro. The industrial kind is good. The heavy-duty kind is good. And I got 1 inch, I think, because it's cheaper. But 1 inch, 2 inch, it's all good. And what we're going to do is take out the hub first. And we're just going to cut some pieces. I think I'll do a strip along each end like this. So somewhere around there. And I have a rule, which is that we have to decide now whether the board, the robot, is going to get the fuzzy side or all of the components are going to get the fuzzy side. And the idea then is if you take something out and you want to replace it, you know exactly what kind of Velcro you need to put on the replacement part. And if we want to move stuff around, like if we decide, oh, hey, this spark, I want to move over to the spot where the other one is, or we want to move one of the Victors with one of the sparks, if they're all the same side Velcro, you can just pick them up and move them. If they're not, you have to replace the Velcro on both sides. So I think I'm going to put the rough side on the robot, and we're going to put the fuzzy side on the device. And if we do that every time, it will potentially save us some issues in the future. So I'll peel off, I stick them together and then peel off the fuzzy side. And then we'll stick that down onto our power distribution hub here. All right, and then we're going to do another set of those on the other side. So let's cut another pair here. All right, and which side is the fuzzy? That's the fuzzy side. So fuzzy side on the device. We'll go over to the other edge here. Put that one on. And just because, again, this is a pretty big and heavy thing, I'm going to put one more in the middle. Okay, and if you're bolting these down, you can skip the Velcro if you want, because the bolts are obviously going to hold it securely enough. All right, so we're going to peel these off. And now, wherever we stick it is where it goes. So before you stick it down, make sure that the power, the main power in, the rev sign, the digital readout, the yellow and green CAN wires are all pointing towards the left side of the robot, the side with the Neo, the side where we laid out our main power. And of course, we could invert the whole thing and put the main power on the other side. Like that would be fine too. But I'm going to stick with the way I laid it out initially. And I'm going to aim mostly for the middle of the board. I'm going to go this way almost all the way. And we're just going to stick that down. Now, realistically, this is probably fine. We probably don't have to do anything else. You can feel it probably too if you did it the same way, but that is in there, and it is not coming off very easily. So this alone is probably good enough for mounting it, but I always like to have a backup here, especially in the electrical system, because anything goes wrong in the electrical system, that usually means the robot is going to stop working, and that's bad. All right. So we're going to go ahead and Velcro this one down next. So we've got our main power switch. We'll flip it over, see what we got. Looks like this one is just going to be one strip along the whole thing. And actually what I'm going to do is I'm going to do the strip on a diagonal so I don't cover the two holes that we might want to drill through and attach something else later. So we're going to go from there to, looks like we need to be about here. Squeeze them together and peel the fuzzy side. Fuzzy side goes on the device. All right, and that goes nicely between the holes, so we can still use those holes if we want to. And we'll peel this one off. And it doesn't really matter which way we flip this around. We're going to end up having one wire from the battery plugging into one of these screw terminals. And then we're going to have a short wire going from the other screw terminal into our power distribution hub here. So I'm going to push this out towards the outside. And, well, that looks good. We'll squeeze that one down. Okay, and this one is lighter, too. And it's, you know, it's pretty on there, right? Like, it's probably good enough with just the Velcro. Let's move to the front. And we'll start with the biggest thing, which is the roboRio. And I really want to make sure that I leave enough room to be able to undo these nuts if necessary without taking the roboRio off. I should have maybe left, I think I left enough room here, maybe a little close on this side. We'll pay more attention to that on this side. But if worse comes to worse, right, we can just peel this off because it is Velcro. It's hard, but we can just peel this whole thing out and then work on those bolts and then put it back. But you do want to make sure that you sort of leave, we don't want to really peel stuff off now. You want to give the glue time to cure. Otherwise, a lot of times what you end up doing when you peel it off is you peel the Velcro glue off. All right, so the roboRio, this is pretty light. It probably doesn't need that much Velcro, but we'll do maybe 2 strips going across it. Something like that. And get the fuzzy side. All right, and one more for this side. Okay, we'll go ahead and peel these and stick this one down. I think we were going to do it this way. I was trying to keep the power lines a little simpler. But, you know, this way is also fine. I'm going to stick with what I did initially. We'll push this up towards the front of the piece of wood here. Push that down. Get that seated in. Perfect. All right, I think the next thing I care about is getting our speed controllers into a good spot. So we're going to work our way along with the speed controllers here next. And this is just going to get just a little strip. Stick it together, put the fuzzy side down. And then we're going to stick this down. And I think we said we were going to do the motor wires towards the inside. And I think we kind of want just to have about an even amount of space. Maybe I'll be slightly more inside because these are pretty flexible. And they can go up and attach to their motors. So something like that. And I'm going to go very, very close to the front edge of the board here to leave myself as much space for the other stuff as possible. All right, we keep going. And we peel it, and then we're going to stick it. Okay, and I'm just going to try to line it up basically even with the one that's there. Looks like it's a little bit bigger, so it'll stick out a little bit on both sides. Again, the red, white, and black side should be on the green and white side, and then the side with the CAN wires should be together on the other side. All right, next one. Fuzzy side. All right, green wires facing in here towards the roboRio. I'm going to leave about an inch, about my thumb's width in between, so I could drill some holes and we can add some zip ties or something else to help hold these down if we want. So that seems like enough room. Squeeze that one down. Okay, fuzzy side on. And once again, more or less line it up. We're going to go right next to the one we just put down. Perfect. All right, now let's do the radio power module. Flip that over. It's like it is exactly 1 inch wide too, so all of these things are like 1 inch wide. Perfect. That one down, peel it off. All right, and this one, right, so we want kind of the Wi-Fi radio pointing towards the radio. But we got a lot of room here, so I'm just going to kind of put it guess we should stick to the plan. All right, we're just going to stick it down kind of a little bit towards the roboRio, leave ourselves some space here. I'm going to keep it so it's not overlapping with the metal frame at all. Yeah, we can get pretty close to the roboRio. That looks good. Let's go right there. Then if we want to add anything else in there later, we can. We have room for it. All right, and then finally, the radio. Now, the radio is a little bit different because if you look on the bottom, it's got all of these feet and standoffs and stuff. So I can't really get Velcro on there because the Velcro will be shorter than the feet. So for this one, we are just going to have to find a way to zip tie it down, which we will do in a second. All right, everything is now stuck down to our board. And we can go through now and add some of these extra zip ties if you want them. Again, right now, all of my stuff is feeling very secure, so I'm not particularly worried about it, but it doesn't hurt to be extra safe. So we'll have to drill holes for this in order to make it work, and we can check and see what size all the holes are. So on the Rev PDH, it looks like our 3/16 drill bit is going to work. And then I'm not going to worry about these holes because those are much smaller, and I definitely don't have bolts for that. And then for these holes, we can go with the undersized drill bit, and then we'll put a washer on top if we have to. So let's go ahead and add some holes now, and then we'll go back and strap everything in. The nice part is, for the most part, we're only going to be drilling through the wood. So wood is not electrically conductive, so if we get some wood shavings and dust places, it should not affect our electronics. OK, so I'm going to go ahead and drill through this hole on the PDH and this hole on the PDH. And I think that's where I'm going to stop. I'm going to maybe get 2. You could do all 4 if you wanted to, but I'll stop there. I'm going to drill through this hole on our main breaker and this hole on the main breaker. All right. And then coming over to the other side, the radio can kind of just hang out for a second. I'm going to drill a hole. If you look on the Spark Max here, there are these little notches, and those notches are going to be kind of exactly the right size to have a zip tie go in and be locked into place. So what I'm going to do is next to the Spark Max, I'm going to make sure I'm not touching it. I'm going to give myself plenty of room so I'm not touching it, but I'm just going to drill right next to that little slot. And then same thing by this one. Okay. Then I'm going to do the same thing here. On this one, right, it has the little groove on the side as well. It looks a little different, but I'm going to go right next to that groove. Again, just leave plenty of room so you don't have to hit it. You don't have to touch it with the drill. Okay, and then on the other side of the Spark Max, we're going to do the same thing. All right, and then finally, the hard part is the radio. We need to be able to zip tie the radio down, and we can change the radio's orientation if we want. We could angle it, we could move it over. We do have to leave enough room to plug those ports in, so it looks like we're kind of stuck with this position, but we should be able to make that work. So one of the things I want to try to do is, remember, there are all these holes in the frame already. So we could try to find some of those holes and see where they'll end up putting it if we drill through the holes that are already there. And I think what's going to end up happening is if we drill through this row of holes, we'll be able to slide in, and then the second set of holes will be just through the wood, and that should work out perfectly. But to find those holes and to drill them, I think the easiest thing to do is I'm going to slide this, make sure the wires are not in the wheels. This time, you could tip it all the way back again. This time, since I only need the very front edge off here, I think I can just roll the front edge off. And I'll do it off this side so we can kind of see what's going on. And I can just come from underneath here. And I'm just going to guess. So we have the bolts that we put on to attach the floor. So we've got 2 bolts here, and then the 1 bolt in the middle, and 2 more bolts here. So one bolt is the frame, one bolt is the floor back here. So it's 2 bolts for the frame and 1 bolt for the floor behind it. But I'm just going to go in from there a few holes, and let's see what that does for us. Does that look like that's going to be in a good spot? Maybe. I'm going to go in. Let's look at the top again, where those bolts line up. Yeah, we're going to go in, I think. So this hole, I know how to do this. So this hole lines up with this hole. So 1, 2, 3. Yeah, that looks good. That looks good. So we're going to go 1, 2, 3. I'm going to drill in the 4th hole here. Okay, and then you should move the radio before you do that. I moved mine. I forgot to mention it, but move your radio. Then I can bring the radio in and see where that hole is going to be. And that looks pretty good. Then the next thing we're going to want to do is, so from the hole we just drilled, we want to do like maybe another 3 or 4 holes over. So I'm going to move the radio out of the way. And so we have the hole we just drilled, which is here. And I'm going to skip, let's see, where's the radio? All right, so we did this hole. So I'm going to want to do like this hole. So I think I'm going to skip 2 holes, and then I'm going to drill another hole. Keep the radio out of the robot for this. Okay. Then if I put the radio back in, those holes will both fit along it. That looks pretty good. We can kind of bring this back around here. So our radio is in. We've got these 2 holes poking up that will be able to run zip ties through to hold onto the radio. And I'm going to put the radio so it's lined up close to those 2 holes, but not blocking them. And then that tells us where we have to drill on the other side. So then we can drill just like before. I've got sort of my distance here, so I'll move the radio. I want to be lined up with the first hole as much as possible. But it doesn't matter if they go crooked. And we'll just drill 1 hole there. And then I'm going to basically turn the whole thing into a rectangle as good as I can. Can slide the radio in and make sure it's kind of in a good spot. That looks decent. I'll move away just a tiny bit more. All right, and that should give us 2 holes that we can use to attach our radio in place. So that means I think everything now is prepared to be mounted. I do want to clean out the sawdust before we actually go ahead and start mounting everything in there. So I'm going to bring my vacuum back over and vacuum out as much of the sawdust as I can. If you have compressed air in the shop, it is kind of also okay to go in and blow out the sawdust with the compressed air. Just make sure you're not breathing it in. But yeah, let's get this cleaned up, and then we'll mount it permanently. All right, now we have all the holes drilled, it's cleaned up. We can actually go ahead and do more permanent mounting of stuff if we want. So the first thing is we put some holes in the PDH, on the opposite corners of the PDH. And one of the problems, though, is the nut. It looks like it almost fits here, but I've been trying to be able to screw into that, and it's just not quite lined up with where we want it to be. So the problem is we have to send the bolt from the top down, which is okay, but it's only okay if you get exactly the right length bolt. Because remember, on the bottom of the robot, we don't want stuff sticking down farther than it has to stick down. So if you can get a 3/4 inch long bolt, that should be long enough where it will just have enough room on the bottom to sink in. On the other hand, if you don't have the right bolts for that, you can always get a zip tie. And if you fish the zip tie through the hole and pass it back up, we can actually tighten the zip tie down. And that's going to be a pretty secure attachment point, especially since if you think about it, the zip tie will stop the thing from moving up. And if the Velcro is engaged, it's not sliding around. So we'll go ahead and do the combination of zip tie and Velcro. So on the diagonal corner, the opposite diagonal corner where I also drilled a hole, I'll go ahead and throw another zip tie in there. And in this case, the board is narrow enough that I can just go around the edge of the board in order to put these in. All right, those look good. And I always like to clip them as we go, but we got to remove all of these tails. So again, I cannot recommend these flush cutters enough. You can go right down next to the zip tie and cut it so there's no sharp end left to poke people or scratch people. There goes the other one. All right, now the power switch, I think we can do bolts into. We got a little bit more space, so our bolts can go up from the bottom. I think we have to use 1-inch long bolts here. And the idea is, once they're on the top, we have lots of room for the nut to fit in. So let's go ahead and tip this up a little bit. And we will kind of screw this bolt in. So you have to tip it up a decent amount. All right. And this is another one where if you had to, you could flip the whole robot on its side. We're just going to go until it is poking out the top. Okay. And if we look at it, I think the nut is going to be big enough to grab onto the power switch, but you can always drop a washer on there, and now you're sure it's going to fit. We'll get that one started. Okay, and the 3/4 bolt might just barely be long enough for this. But I think with the washer, it might end up being just a tiny bit too short. So let's go ahead and drive the other bolt in, or screw the other bolt in through the wood here. Okay, so that was the 3/4 bolt, and we can see it is too short. So we'll pull that one out. Now we know. It's like the 1 inch is the size we need. Okay, switch it over to the 1-inch long bolt. And these are all 1032 bolts. We're sticking with the same size. You could probably get by with significantly smaller or lighter bolts. But this robot does not have a weight problem, so there's no reason to worry about it. Right, drop another washer on there. We'll get another nut started. All right, I'm going to tip this back down here for a second. And I'm going to get the angled, the L hex key, because that I can fit underneath the robot, unlike the handled one that I was using. And I should be able to get this into a spot here. All right, that's in, and now we can start to tighten this down. I still have room, a little bit of room on the bottom to turn, and I'm still also turning the wrench kind of on the top a little bit too. If you have a socket, 3/8 socket would be probably a really good choice right now. But we've come this far, so we should be able to get it to work. Also, turning the robot on its side might be worth it. We are getting very close. Okay, that one looks good. We'll try to get the other one. Maybe let's see if I can get that one corner off the edge of the table so I can reach up from the bottom. It's fine if I hold it. All right. Okay, and I'll use the handled one from underneath this time. Go a little faster maybe. Okay, and no need to over-tighten it. We are in and good on that one. So that's the basic idea. If you want to bolt stuff, if you find the right size bolts, you can go that way. We're going to go ahead and do zip ties for the other pieces over here. And the roboRio, I think I'm just going to leave. But you should keep an eye on yours. If the roboRio or the radio power module start getting loose, you might want to add zip ties for them as well. All right, let's go ahead and go down through the hole we drilled here. And then we got to kind of reach under to fish it back up. Okay, there it is. All right, and this zip tie, right, will go down, and we can kind of get that zip tie into the grooves. And that will also lock it down. And realistically, again, you're probably fine with just the Velcro. You're definitely fine with the Velcro and one zip tie going through it. But since we drilled the hole, I'm going to go ahead and do all 4 zip ties for our speed controllers here. This one is a little harder because we're going to go from one hole to another hole. So you may have to lift the robot up or tip it on its side to be able to get the zip tie to find its way. And we'll do one more here. All right, those speed controllers are not going to be falling out of the robot anytime soon. The last thing we have to get right now is the radio. So we've got to kind of fish 2 more of these zip ties around. And the radio doesn't have to be there yet, so it's a lot easier for me to get them started when I can see what I'm doing. Allegedly. There we go. Okay, slide the radio in. Remember, we want the ports on the radio facing this way towards our roboRio and everything else. And then we're just going to go ahead and zip tie that down. Now with the radio, I like to get the zip tie. I try to move the zip tie around until it ends on the corner. Just feel like that's a little bit nicer. But if you don't end up that way, it's not a big deal. Okay. And the other thing with the radio is it's in, it's secure. It doesn't have to be super tight. Make it tight enough that you can't wiggle it too much. But we don't want to crush the case down on the radio. We're not trying to make this as tight as possible. All right, that's not going anywhere. Our radio is very light, so crash into something, there's not a lot of inertia there, not a lot of momentum to make it keep moving. All right, so that is everything now anchored down. Our next step is to actually start connecting wires. So let me get rid of these tools that we use to mount stuff, and we'll come back with our wire. All right, now we're ready to start connecting the wires together. And to do that, we're going to be using these. So these are Wago lever nuts. And they're really cool because they work kind of the same way that the power distribution hub works. If you lift up the ends, you can slide a wire in and then close it down, and it locks down on the wire. So really, all we have to do is strip wires to get to the bare copper, or I think these are all copper wires inside. And then we just clamp it on with this. We don't have to do any soldering. We don't have to do any crimping. We don't have to do anything fancy. Just use these everywhere we want to connect two wires together. So I've got a big bag of them. And these connections are great, too. I use them in my house, too. So I'm a huge fan of the Wago. These are 221s. All right, we'll also need some wire strippers. So there's a good chance you have ones that look like this, where you cut in and then pull. And then I've got some automatic ones where you slide the wire in and you just squeeze and it does everything for you. So I'll start with these because that's what I would imagine most people have, but I'll switch to these because they're so much faster. All right, so we'll slowly work our way around doing all of the wires that we need to do. And we're going to start with the 4 motor controllers here that we have coming out. We've got all of these wires here. And one of the things that we want to do is we're going to wire up 2 of them to, well, all 4 of them are going to go to these drive motors. So let's get these drive motor wires kind of untangled here. And we want to make sure when we're doing this that we don't mix up the wires. So each motor has 2 wires coming out of it. Those 2 wires have to go to 2 wires from one of the motor controllers. So we can't like get a red wire from this one and a black wire from this one. We can't put the red wire with this motor controller and the black wire with this motor controller. We have to take extra time to make sure that this is not mixed up, because when you mix stuff up like that, it still half works, but it will do weird stuff, and that potentially could be very confusing to troubleshoot down the line. So we're going to do one at a time. So all these other motors are out of the way. I just have this one motor, and this is on the right side. And we can go ahead and decide, right? Like, should we do these as the right side or these as the right side? And for me, I think I always go left then right. So from front of the robot back, I think these 2 should be left. So I'm actually just going to write an L on my board next to those. And then these ones down here are going to be my right ones. So I'm going to do an R down here and maybe a little arrow just so I don't get confused. These are lefts. Those are rights. And it doesn't matter, of course. You can pick however you want to do this. So we're going to start with the first Victor, which is the white and green wires. And we've got the 2 red and black wires coming out of the sim motor. Now, you could cut these because we don't need much distance. We could cut them and then just attach them and not have any extra wire in the robot. That's fine. That is marginally better because you'll get slightly higher voltage to the motors. But I'm not going to do that because I don't know where these motors are going to end up on my next year's robot when I have to use them again. And if you cut the wires, it's harder to make them longer again. And especially on the motor controllers, I would definitely recommend not cutting these wires ever. Because if they get damaged, you'll have to cut them just to get away from the damaged part. And once you run out of room on these wires, that's it. There's nothing else you can do. So let's go ahead and get our wire strippers here. And I guess the motor wires are already stripped, so we don't have to do anything with those. On the other side, though, we're going to strip these wires down. I think these are either 12 or 10 gauge wire. And what I always do is, if I'm not sure what it is, I'll start on the bigger size. And to strip wire, basically, we're going to go down about ½ an inch, about that far, and squeeze it, and then pull. And what you're looking for is, did any wires break off, or was it just the housing? And in my case, I think just the housing came off. So that looked like the right size. I was in the 10 for stranded gauge. So I think this is 10 gauge wire. And we're going to do the same thing on the green lead now. So we'll squeeze that in and pull it off. Looks good. All right, and then we're going to grab 2 of our Wago lever nuts here. And just go ahead and open up both of the little doors, both the little orange flaps. Just pull them up. And you can actually look on the bottom to see what's happening when you put this in. So I'm going to slide the green one into one of them. And I can see when the wires are in far enough, like that metal tab is going to go down. So I really want to kind of shove this in all the way for me. I don't want to go so the insulation is touching it, though. All right, and when that's pushed in kind of all the way, you just lower the lever. And once you lower the lever, do give it a little tug. If it doesn't fall out, you're good. If it falls out, just try again. All right, then the other side of the green one here. Now, technically, it doesn't matter. If I put the red wire, normally it's green and black are both our ground wires, and red and white would be our positive wires. But if I connect the red wire here, the only thing that's going to do is it's going to change the direction that this motor spins. So forward will be backwards and backwards will be forward. But actually, 2 of our motors are going to be backwards anyway. Our goal is to fix all that in programming, though. So just to keep everything straight, we need to make sure that these 2 motors are plugged in the same polarity. So when they spin together and they don't fight each other. And the easiest way to do that is to just stick to the standard colors. So I'm going to take, on the other side of my green one, I'm going to take the black wire and slide that in. And then snap that one shut and give it a tug test. Looks good. Then for the other one, let's open our other lever nut. And this one is going to be the white wire. And you only have to twist them if it doesn't go in. You don't really need to twist them for this. But shove that in, lock it down, tug, we're good. And then the red wire, and we'll put that one in. And tug. All right. What I want you to do is make sure, double check that you have both coming from the same speed controller and both coming from the same motor. And when you've got that, we're ready to do our next one. So I'm just going to kind of tuck these out of the way so I don't get confused by them. Now we're moving on to our Spark Max. Now for the Spark Max, we have this extra wire. We're going to ignore the white wire. We're just going to connect the red and black wires. But it's the same process. Get your wire strippers. We are looking for about 1/2 inch of wire. And go ahead and strip it. Same thing for the black wire. Okay, and if you strip too much off, it is okay to, usually your wire strippers will have a little cutting section on it. Or if you've got the little flush cutters, you can cut, however much you need to off of it. But when you're cutting that, don't do it over the robot because you're going to litter a bunch of little metal wires all over everything. So make sure you're maybe like in the middle here where it'll fall down through the robot, or have somebody, with their hand or a cup underneath it. So when you cut them, you can contain them. All right, 2 more lever nuts. Open them up. We'll do the black wire first. And I like my lever nuts upside down so I can see what I'm doing. Push that in. And lock it down. Tug on it. And we're doing the other motor on the right-hand side. So make sure you get the other motor on that side of the robot. Get the black wire. And we'll feed that in on the other side. Push it, lock it down, give it a tug. Looks good. All right, and then we're going to do the same thing for the red wire. Okay, it needs a little bit of a twist. They're spreading out too fast on me. Push that in, lock it down, tug. Get the red wire. Make sure it's from the same motor on the right-hand side. Feed that in, lock it down, and tug. We're good. All right, that is the second right motor done. So I will also kind of tuck those. We'll tuck those in here so they stay out of the way. All right, we're going to do the same thing now for our 2 left motors. Oop, that one failed the tug test, so that means I probably didn't push it in all the way. So no big deal. We will try again. There we go. Sure it's from the same motor. One's looking good. Last one. And if you get ends that are so crazy that you can't kind of bring them back to looking good, you can cut this wire and then strip a new section off. Didn't get there on that one. All right, now that all 4 of those wires are in, we kind of want to manage these wires so that it's not such a big mess inside the robot. So we're going to use some more zip ties for this. And there is no right answer for how to do this. But I'm going to kind of take this group here, and I'm going to look to bundle this group up out of the way. And then I'll sort of bundle this group up separately out of the way. So one of the things is you never want to be pulling tight on the wires. You never want to see them strained like that. Always leave yourself a little bit of space. Let's see. So if we kind of just come over this way like this, we could zip tie those down to the motor itself. Kind of come back. I don't really want them to be sticking up, though, if I can help it. So maybe we'll come down onto the side of the motor. So I'll bring this one down underneath, and they'll both come to the inside of the motor over here. And then we'll give it a little bit of a loop. Like that. And I kind of want to leave the actual connectors free as well so that we can get to those if we need to. All right, so you just play with it until you kind of get it to a spot that you're happy with. That looks like maybe I can work with that. And then we'll try to pass a zip tie around the motor here. That's pretty good. And then I think I will also do a zip tie to our zip tie that is anchoring everything in over here. So for that, I can just use one of the tiny ones. There they are. Just kind of come around this zip tie and we'll anchor this side in place. We'll take a second to sort of gather the wires around the way that I want them to be. And we'll get a nice little bundle there. All right, and we can just sort of tuck the rest in for a rainy day. And some of this is not necessary. If you just have the wires plugged in, your robot's going to work. But it's going to be easier to troubleshoot and find mistakes if you take some extra time like this. Okay, and this wire, Probably also should have bundled that up, but I'll sneak it into these zip ties that are already here, like that. Okay, now for this section back here, I kind of, again, like trying to get a lot of it attached to the motor, but I want the extra bits to run sort of this way. So that's my goal. And so that seems like this is what we want to do here. These ones are a little bit long, so maybe we'll flip them back over one more time. That looks good. Again, I'm going to keep it generally down, so if we have to add anything on top of this, the wires won't be in the way. And we'll just pull those tight. All right, and then on the other end, I think we'll do the same thing we did before, which is we'll do a little tiny zip tie over here, which will kind of keep them out of the way of our roboRio, so we have room to work on. We can access the CAN port and all that stuff over there. And this time, because I'm remembering it, I'm going to take that extra white wire and put that through that zip tie as well, just so it is a little more contained. Perfect. Okay. Those are wired up. Now, we have the other sides to deal with, and so we can start working on that. Let's untangle this mess that's over here. And we really want to find each one should have a red and a black wire, and then it should have 2 yellow and green wires coming out of it. So let's get them all separated out so we know which is which. All right. And all of the red and black wires, we need power, so they're going to come over to the PDH. But all of the green and yellow wires are going to connect together to each other. All right, so now we're going to actually start to plug these in. And the way to think about it is we're going to start our CAN at the roboRio, in the CAN port on the roboRio. It's going to go to this first SparkMax, which is going to go to this first Victor, which is going to go to the next SparkMax, which is going to go to the next Victor. Then that Victor is going to actually have to go all the way up to this motor, where we're going to have another SparkMax that we haven't mounted yet. That one's going to go up to the intake. Then we'll have wires coming back down from that one that will go into our PDH in the CAN port. And that will connect everything together. So we're kind of daisy chaining. It goes from one device to the next. They don't all plug in the same place. So really, I don't think it matters which side we use here. So what I'm going to do is I'm going to start with, I guess we'll start with the pins on this device, or maybe we'll do the other way because, yeah. All right, so the side without the pins, we're going to leave that alone on this first SparkMax. That is eventually going to go into our roboRio. Then the next part of that one was the side with the pins. Let me tuck this down underneath here. And that one is going to go, if you get the 2 yellow and black wires from the Victor, we can find the one with no pins and go ahead and just plug them into each other. So it should be yellow to yellow and green to green. Just double check after you plug it in that they went the right way. Okay, and you can take this connector piece off here. And all we're going to do with this connector is you're going to slide it over both of those pieces at once. And if you're in the center, when you push it all the way in, it'll sort of snap into place. What you'll notice is now this connector can't be unplugged. So those cables used to come unplugged all the time, but now with this connector, they are locked in and not going anywhere. Okay, so that is our first CAN joint or connection made. Then we've got the pins coming off of this one. What we need to do is find the 2 yellow and green wires coming off of our second SparkMax, the one for the right side of our drive. And we're going to do the side with the holes, and that is going to connect with the pins that are left over, green to green, yellow to yellow. And then you can take the other connector that is on the other one here, or in this case, we can grab one of the white ones that came in the SparkMax boxes. SparkMax boxes. All right, and that one just snaps in the same way, locks it together. All right, and then we have the output from that spark, and we just need to find the one on the Victor to plug it into. And that looks good. And we can use the other little tab. Line it up, push it on. There we go. All right, and we are locked in. OK. So all of the CAN wires that we just did, we can kind of tuck underneath what's there. Leave the power wires up on top so we can see them. So we can keep working with those in a minute. And really, we can choose to route this however we want. I guess I'm going to come back. No, I'll go around. We'll just go around. It's fine. There is no one right way to route your wires. Okay. And my thought is I'm going to take all of these wires, all of these CAN wires that we have, and kind of pass them underneath the other wires, and then I'm going to bundle them up on top of this first SparkMax. So the only one that is going to be free still to roam around is the uncovered end. So this one should stay on this side, and then this one will be heading towards our roboRio, where we'll attach it in a little bit. And so those are all bundled up. I'm going to get a zip tie to go around those. And I think the easiest place to zip tie it is I can just latch onto the one that we use to hold everything together. If you didn't do that zip tie, you can actually drill holes in the board just for these zip ties to hold your wires down. You might be able to also find another spot, maybe on the inside of the frame here where you could attach it. But this looks pretty good and out of the way. I'm going to snip some of these zip ties. I think we didn't do these several steps ago. There we go. All right. Next step, let's finish this one up by getting it into our CAN port over here. And there are a couple different ways we can do that. So one way is, I think you got in your kit apart some of these PWM cables, and it looks like there are 4 of them. So we're going to need one of these for this motor, and we're going to need one of them for the other motor, but that does mean we have 2 left that we can use for whatever we want. And the thought here is, if I take one of these, just one, and plug that in this case, white is going to be yellow and black is going to be green. Now I have just enough extra wire where I can get over and plug this into the CAN port on our roboRio here. All right, and in fact, well, I think we're going to run out of these connectors, but we can go ahead and throw a connector on here to stop that one from falling apart. And all we need to do is measure this out so that we have enough to get to kind of our input here. And then, well, there's no going back after this. I'm going to cut the wire. And what we have to do now is you can peel apart the red, black, and white wires. So I'm going to peel it back just a little bit. And the red wire we don't need. You could actually peel out all of the red wire, but I'm just going to peel it back a little bit, and then I'll snip the red wire so it's out of the way. Okay, and then we're going to come back, and we are going to strip both the white and black wires here. And I'll switch over to these ones because I needed a smaller wire stripper for this step. Okay, and actually a little more than that would be good. Okay, and just go ahead and strip both of those. And the way these connectors work is if you push down on this white part, you should be able to slide the wire in, and then when you let go, it should lock into place. So the easiest way to do that is with, if you have a little screwdriver. There's also, well, there is a Wago tool that you can use specifically for it, but I'm going to get a little screwdriver that I can use to push down on that white bit. And remember, this one is yellow, and yellow for me is the white wire. So we're going to push down on this and then slide the white wire down, straight down into that hole, and then let go. And then you want to give it a tug. If it doesn't fall out, you got it all the way in. If you didn't, try again. And then let's go ahead and do, the black wire is our green wire here. So we're going to push down on that. Feed that wire straight down into that hole. Oh, I'm getting some of the strands caught, so I'll give it a little twist. And let's try again. There we go, all the way down. Let go, give it a tug. It's not going anywhere. So those wires are now secure. And maybe at some point we'll add one more zip tie just so that can't move around at all. All right, that looks good. Now we got to get some other wire so we can start to attach the motor power all the way over to the power distribution hub. Okay, so once again, black is green. Green goes on the top here, so I'm going to start with that one. Just push down on this tab to open it up, and the wire should drop right in. Let go and tug test. We tug test everything. That is seated. It did not come out, so we're good. And then white is yellow, so we'll drop that in the other spot right here. All right, looks good. And then I might come back at some point and zip tie this down, maybe to these other bigger wires. Just don't like any loose wires floating around because that's an opportunity to get stuck. And this CAN wire is extremely critical. If this CAN wire comes out, robot does not move anymore. If one of the motors comes unplugged, you can still move the other motors, but the CAN controls all of them, so that one is important. So I guess having said all of that, let's go ahead and get one more zip tie, and we'll come around this bundle of wires here. And I'll go right to, maybe right to the connector on there. So that'll hold it down and keep it from moving around on us. All right. Next up, we are going to do our power wires. And we've got, that means all of these red and black wires over here are going to need some wires that will travel across the robot and go into these ports over here. And what I think comes in the Rookie Kit of Parts is this, connected wire. You get a red and a black, and they're sort of fused together or connected together. You can sort of like peel them apart just like we did with that other cable, that 3-wire cable. But we're going to work our way through here. So we need to kind of figure out how much of this wire we want. So let's work our way from where it's going to go. So it's going to go from, and we could try to plug it into this side if we're able to, which is definitely a possibility. Right? It's a little close. Or we have to come over to this side. So if we come over to this side, we would need about that much wire. We need a little bit of a loop. It would have to cross over to here. And then these wires would connect to it. So we need pieces that are about this long. And if we did this side, well, it would be a little bit shorter. But I think I'm going to go with where it's easy to plug in instead of worrying about getting a few inches off the length of the wire. So looks like something like this is going to work for all of the wires. So I kind of have that marked with my thumb here. I will cut that. And then we're going to kind of work our way over and see if it worked out. So first thing is I want to split these apart. And if they're really tough and you can't just peel them apart with your fingers, if you kind of get in between them, you could use a razor blade. You could use even scissors probably. I think usually if you get them started, they start to peel a little bit after that because you got something to grab onto to peel them. So there we go. Those are peeling back. We need to peel back enough that we can sort of work each wire individually when we go in here to plug them in. And on the other side, we need to do the same thing so that we have them peeled back enough so that we can put them into our Wago on the other side. Let's snip that a little bit more. All right. So we'll make it about the same on both sides, because then it doesn't matter which way we flip it. All right, and just while I'm out here, because I can, go ahead and strip these wires. And we want to strip about the same amount that we have been stripping. So, that about 1/2 inch. And then we'll flip it over and do the same thing on the other side. Okay, that one was a little different. There we go. All right, so everything is stripped. Let's come back into the robot. And I'm going to start with the farthest away one, because if that one reaches, then we know our wire is only going to need to get shorter from there. So make sure you get the red and black from that very front Spark Max. And we're going to go ahead and strip those wires down. And then let's get ourselves 2 more of these lever nuts. Feed that in, close it, give it a tug, we're good. We'll do the black wire next to it, or opposite the first black wire. Tug, we're good. And now let's do the red side. Looks good and looks good. All right, so that passes our tug test here. And let's see. We have a couple of options. We can go across the top like this and bend it back and plug it in. Or we could fish this. Let me keep this green one out of the way. We could fish this underneath our panels here. And come up on the other side. So we're just going to kind of go underneath where the motors are. And this is completely up to you. Part of it, I'm just trying to keep the top of the robot cleared out. Because I don't know, maybe you want to add more stuff there later. All right, and so this is working. And let's see, we'll go with this front set. We'll start kind of on the inside. So we have 1, 2, 3, 4, and 5. So I'm going to go in, so number 6. And the best way to do it is if you look directly at number 6, go ahead and open those 2. And it should be red towards the right and black towards the left, because you don't want to accidentally connect it this way, because what that would do is give us 1 wire on port 6 and 1 wire on port 5. So the red wire should be towards the right side of the robot. Okay, and then we're going to come in with our 2 wires here. And just like the lever nuts, really, we're going to pass the red wire in to the red spot and lower it and give it a tug test. And then we're going to do the same thing with the black wire. And tug test. All right, those are in. And we're going to kind of do, I actually kind of like this idea too. It can kind of run along the side of the board like this. That looks good. I like that. That looks prettier than going over the top. All right, so that is 1 set of those wires done. Now we're going to just keep going. We're going to work our way through all the rest of these pairs of wires. And one thing we can do too is, since we are going to just be building from one side to the other, what I think we can do is if I take this wire and I pass it under the motors to start with, see if I can get that to come out the other side. Kind of put the bend in it. Maybe it'll pop up for me. No, all right, I'm going to tip the robot up a little. Oh, there it goes. now we got it. All right. So this is going to come underneath where our other wires are routed, right? And so what I can do with these wires is, now that they're inside here, we're going to split them apart. And then we'll just connect them. And then what we'll be able to do is we'll be able to cut the wires on the other side to the exact length we need. So let's get these stripped. And so now these two wires are from the first Victor. So our second left motor. And let's get more lever nuts. Just don't forget to tug. All right, and what we can do now is, as we pass this around, we'll kind of bring those in line with our other connectors that are there. And we know this is going to go down here, around here, and we're going to plug it into the next port in. So we only need this one to be kind of like this long. So I'm kind of measuring to the back of the port here, and that's where I'm going to cut my wires. Okay, then we have to split them apart. And we got to strip them. And then I'm going to lift up the next two spots on the PDH here. And we will reach in, feed the black wire in. Lock that down. Oh, did not survive the tug test, so I probably did not push it in quite far enough. We will try that again. Make sure we're all the way in there. There we go. And then the red wire. And that's good. All right, 2 down, 2 more to go. Okay, once again, I'm going to feed the wire in from this side, keep all my excess wire on this side. Feed it through. We're going to split this and strip it. A little more. All right, and then I'm looking at the next Spark Max. Make sure you get 2 wires, red and black, from the same motor controller. This is going to be the first ones for our right side motors. A little more. And more lever nuts. Tug test. tug test. All right, and we're going to bring this wire back through. And again, I'm going to stop roughly when the connectors are lined up with my other connectors, so we can have a nice bundle of connectors right here. And then we're going to measure this one as we wrap it around. And that's where we cut it, at the end of our board here. Split them, strip them. A little more. Okay, now 1, 2, we're lifting up number 3 and 4. And again, we'll get the black one in first here. And give it the tug test, looks good. And then the red one. And tug test. All right, that one is also good. So we got all our loops building up over here. Looking good, looking good. And one more. We've got our 4th drive motor still to go. So we'll fish this wire through. And split and strip. Okay, and then we've got 2 more motor controller wires hanging out in here. For our last Victor, the last 2 for the right side, let's strip those now as well. And then get the lever nuts. The tug test looks good. I'm going to get that roughly bundled up with actually, wait, I want these wires to be on the other side. So they're just kind of tangled up. This is totally not necessary. You don't have to move them if they're tangled up, but I really want them to go under this whole bundle, and I did not. So I'm just going to undo the lever nuts, redo the lever nuts, and we'll be fine. All right, so these are going to come down like that, around. And this time we're going in the very first 2 spots here. So that looks pretty good. I'm going to leave a little extra on this one because it's a tighter corner. And I want to make sure there's enough wire to go around the corner comfortably. And then we split this side and strip it. And then we'll feed the black wires in first. Tug. And red wires. Tug. Looks good. All right. The next thing we're going to do is, of course, any of these ports is fine. So if you want to spread your wires out or you want to plug them into different places, you can go ahead and do that. Just make sure you have the red and black pairs correct. All right. Then these slots inside here are for circuit breakers. So this is going to protect it if there is too much current running through it. And the circuit breakers we're looking for are in this bag. These are 40 amp auto resetting breakers. And I think they come 4 to a package. So that is exactly what we need for this set of motors. And you'll be able to see on the top of them, it says 12V40A, and the side also says Rev40A. So you'll know it's a 40 amp breaker. You can also buy 30 amp breakers. But all of the motors we're using on this robot, we're just going to do a 40 amp breaker and with wires for a 40 amp breaker. All right, so we'll go ahead and take this, and it's just like when we were putting the fuses in over here. You can, if you look down, you'll see little metal slots for it. And it doesn't matter if the breaker goes in facing this way or facing this way. Doesn't matter which direction it's facing, it works both directions. But all you want to do is sort of wiggle it in until it's nice and flat. Okay, and that was, remember, we're using 9, 8, 7, and 6. And again, I could flip this one around, but just because I want them to all look the same, I'm going to put them in so that the writing is all facing this direction. All right, fuses are in. Next step, let me get rid of some of the mess we made. And then I think we'll come back and we'll try to wire in the main power from the battery. OK, next pieces we're looking for are, this is our main cable. The battery will plug into this end. And we have 2 wires coming out. And then we're looking for this one. This, I think, is a 7-inch long. It comes with ring terminals on both sides. You might not have gotten this. In that case, you might just have 6-gauge wire. And you might have some of these ring terminals that you'll have to put on and crimp. If that's the case, strip the wire, slide the ring terminal on, and then smash it with whatever you have to smash it. You can crush it in a vise. You can try to use pliers or vice grips. It's pretty hard to tighten it on this thick wire, though. That's why we kind of got this one, because it's sort of ready to go. We're going to cut it off and just have to strip one end. Now, if you're using the other power distribution panel, not the Rev one, but the across the road one, you actually need ring terminals on both sides. So if that's the case, don't cut yours off. And you'll be able to use it just the way it is. All right, let's get started with this. So inside the robot, the way it's going to work is we have this wire, or this connector. I think you can actually bolt it onto here so it doesn't move around on you. I don't know if I'm going to do that because it's not super important that that gets done. And it looks like it's going to be very close as well. But the black wire, we're going to go directly into the Rev panel and lock it in. Again, if it were the cross the road panel, you'll need this to be able to screw into it. So don't cut this off if you're using the cross the road panel. And so the black end goes directly into the power distribution hub. The red end is going to go into one side of our power switch here. And then the other side of the power switch is going to come into the Rev panel. So we'll lift those up just to remind us. Now here's the one issue, and that is I think I might have put this far enough away that it is going to be very close as to whether or not you're going to be able to actually connect that onto this bracket up here. But that's OK if it's kind of flying free. A lot of times that's the way the robot's going to work. All right, and we need to undo this. So we're going to have to find the socket that fits on there. And I'm not sure what size that is, but let's see if we can figure it out. Looks like that is a metric size. So I have a 10 millimeter socket. You could use a 10 millimeter wrench as well, although it takes a long time to kind of unscrew it if you're using a wrench. So I'm going to get these started. And once you get them going a little bit, you should be able to loosen them up with your fingers. Okay, and there are 2 nuts, and then underneath the nuts are, these are split washers. And these are supposed to help keep things tight, keep pressure between it. And we're going to lift all 4 of these pieces off of the switch. Okay, and then on one side, we're going to take that red wire and put that connector. So the one with the battery connector on it, this is a big Anderson connector. We're going to slide this one on till it goes all the way down. Then drop a washer on, and then go ahead and start the nut going. And get it close, and don't lose the other ones. And then you're going to go ahead and tighten this down so it's pretty tight. I'm going to spin this a little bit because I want my wire to be going off this direction towards the center of the robot. And then we'll come in and we'll tighten it up the rest of the way. Now, this is a tricky one because it needs to be tight, but I have had people try to tighten it so much that they actually just break that stem, the bolt that's sticking up, right off of it. So make sure it's snug, give it a little bit of an extra tug, but don't like crank on it with all of your strength. But you definitely don't want, if you look at it, you should not be able to rotate this connector. This connector should be locked in place. If this rattles around at all, it's not tight enough. Tighten it a little bit more. Okay, then, like I said, we're going to take the black end of this wire, and that is going to go into the Rev PDH here. So what I'm going to do with that is I'm going to look, I don't know, somewhere around here feels very comfortable, so I'm going to cut it right around here. If you have a use for another black wire like this, you could probably cut it a little bit shorter and have a little bit more of that wire left over. But I'm going to cut it up here towards the end. And this one is going to be difficult to cut. I'm going to have to kind of do it a few times with this thing. If you have bigger cutters or diagonal cutters, you'll probably get through it a little faster. But I'm going to cut a little bit at a time. And there we go. Now, we have to strip this enough for it to go in there. We need to strip a decent chunk of this, about maybe 3/4 of an inch. If you only have these kind of wire strippers, you have a couple options. You could take a utility knife and try to score it all the way around and then pull it off. I like to actually use these. You can use the cutting section to kind of do the same thing. You just don't cut hard. But really, I find it works better if I go to the biggest hole I have on there, and I'll just kind of squeeze in and then rotate a little bit and do the same thing. And I'm just going to do that all the way around the wire. And when it starts going a little bit, I'm going to, maybe try to twist this a little bit to see if I can get it to move. Move to a new spot, try it again. You can see we're slowly cutting it. We're slowly getting it to move here. I think I need to aim for this area. And once again, I'm not squeezing hard because I definitely don't want to cut the wires, and it doesn't take much to cut through the plastic insulation on here. All right, and that is pretty good. I think if I can maybe even run just the blade part, the cutting part through here. But I think if we start really working on that and pulling on that, we'll be able to get it to pop off. Keep wiggling it. There we go. All right, and probably I cut a little bit too much, and that made life a little bit harder. You can also look here. If you have a bunch of cut strands, it means you kind of went too hard. Maybe try a different method or be a little bit more gentle with it. Now this is going to go right into, let me give it a little bit of a bend here so it can go straight in. It's going to go into the PDH. And you can see, so you probably can't see from your angle. When I put this in though, what can I use to show it? It went in, that's too short. It went in and I could just see a little tiny bit of copper poking out. That means I stripped too much. If you put this in and you see some of the bare wire still sticking out of the box, that means it's too long and we're going to trim this down a little bit. So I'm going to bring this again outside of the robot so that all of these little copper bits aren't going to be falling in the other electronics. And I'm going to cut about 1/4 of an inch. All right. So that is probably a better amount to strip. All right, now we'll try again. This time, slides in all the way. I don't see any exposed copper, and the tug test has passed. Okay, I think I want to kind of get this wire to go maybe under the other wire. I think I like that. There we go. And then we could still get over here and bolt onto this if we wanted to. Don't know if we can do it facing the other way, though. That is, yeah, maybe it just makes it. But I think theoretically this should work either way to attach onto here. OK, so that side's done. Now we need to go from the other side of our power switch into the other port on our Rev PDH here. So let me get rid of some of those wire shavings. And we've got the same job to do. This we'll be able to bolt onto here, right? And then we just need to snake it over to there. We might want to make it go so that this is tight, and we might want to have it bend around and back in. That could be good. I think we want to keep most of the length of this one. So while it's outside of the robot, it's a little bit easier for us to work on. And what we're going to have to do is the same thing. You can kind of feel where the end of this wire is. And it's kind of like that groove there. And I'm going to basically cut right below that on this wire. And again, if you have 6-gauge wire and the connectors, you can do that. I have a lot of trouble with teams getting those connectors nicely crimped. And since this is the main power delivery for the entire robot, right? Like, I like to make sure that we have a really solid crimp there, and buying the pre-made connector and cutting one end off works a little bit better for that. So we can take this heat shrink off as well. And now we just have bare wire on that side. So the same way, we're going to kind of cut around and then try to pull it off. I'll do this one using the other method, just so you have an example of both and you can decide which one you prefer. So here, we're going to use the utility knife, and I'm going to kind of aim where I want it to be, and you just sort of cut in and spin the wire. We'll go around one more time, and that looks pretty good. If you have a sharp utility knife, this works well, but you can still cut the wire, so you got to be careful. And then you still got to do this like wiggle it back and forth thing to get it off. You could probably use pliers once you get enough of it off the end to kind of grab onto it, and that helps a little bit. But no matter what, it's going to be hard. All right. And I think, too, what happens is when we pull the end off, it also pulls the wires through a little bit. So this looks like it was a little bit longer than what I tried to strip, but that's OK. All right. Now, what do we think is the harder thing to do when we are going to be tight on the wire? I think actually it'll be harder to put it into the Rev PDH. So let's go ahead and do that side first while the wire is free. So we'll slide that in, lock it down, tug test, it's good. And now we just need to fish this wire around however we want so that, right, we are on our post over here. That looks pretty good. I am good with that. All right, drop that split washer on, and then we'll start the nut. Okay, and then bring out your socket, 10 millimeter. And again, we're going to make it tight. And I'm going to give it a little bit more, and then I'm going to stop because I do not want to break it. And then you can put these little hats on to try to keep it insulated as much as possible. Now, you might have inspectors that don't like having this stuff exposed, so they might have you cover that with electrical tape later. You could do it now if you want to. I'm not going to. This is pretty safe. I'm not really worried about danger here. And I don't want to kind of cover everything up until we've turned it on and we know it works. So that's something to think about when you get to your first event if the inspector asks you to do it. All right, so that is main power done. I guess now we can jump back over to this side of the robot, and we can work on, we're going to need power lines for the roboRio and a power line for our radio power module here. Next thing we need to do is we need some 18-gauge wire. So I should have mentioned this before, but the gauge of wire is basically a measurement of how big it is. So 18 gauge is smaller. So the bigger the number gets, the smaller the wire gets. 18 gauge is smaller wire. Earlier we were using 12 gauge wire, which was bigger wire. Bigger wire lets you carry more current. So if you have something attached to it like a big motor that's going to be pulling a lot of electrical power, you need bigger wires for that. Now, though, we're going to work on our roboRio and our radio power module, both of which are fairly small and don't need a lot of power. So we're going to use 18-gauge wire in order to power them. Also, the manual, the rule book, has sort of dictated the wire sizes that you need to use for stuff. You can always use bigger, but you can't use smaller than what they say. So we're going to do some 18-gauge wire runs coming across the robot to get to our power distribution hub over here. And, well, I'll start with this one that I've got. And let's kind of look at where this is going to go. So this wire is going to need to go from the 2 ports we put these fuses into, so 20 and 21. And one of them has to just kind of get to the roboRio that's right here. So that's a pretty short wire. We can make that run. And then the other one will probably travel with it, but it's going to need to go much longer. And eventually, I probably want to leave room for it to go around like this so we can have pretty wire lines. But that's going to go into the radio power module over here. So I think the easiest way to do this is, once again, let's wire them up one at a time, and we'll cut them when we get them to the length that we need. So first one, let's do the roboRio power. So again, we need to peel this apart. If you can just do it by hand, that's fine. If not, go ahead and clip it first so you get something to hold on to. And we'll peel this apart a little bit. So this one is going to go into our roboRio. All right, and we're going to strip those wires. This time, we're going to strip them a little bit less, maybe. We'll see. I think that's about good. Somewhere around there. All right, and if we jump over to our roboRio with these wires, we have, it says input 7 to 16 V 45 watt max. And then there's this black connector to it that says V and C on it. So the V stands for positive voltage, and the C is for common or ground. So we're going to put our red wire in the V and our black wire in the C. But in order to do that, we actually have to take this connector out. So there are 2 flathead screws on the 2 sides of it that you can go ahead and unscrew. And that will let you pull this whole connector out. And then, once again, we have our V and our C. So black wire is going to go into the C, and the red wire is going to go into the V. And you can see I pushed all the way in, and I still see copper wires sticking out. So we're going to trim those by about the amount of copper wire that I see sticking out. Again, we always do the wire trimming outside of the robot, so I'm going to come over here to do that. And we'll just trim off about the amount we saw sticking out on both of them. All right, back into the robot. One more time. We'll do V red, C black. And this time, they're all the way in. I can't see any of the other wires. Now, if your wires don't go in, the way this works is there are the screws that we use to take it out, which are next to V and C. And then if you turn it, there are 2 screws on the side. And when we tighten those screws down, they're going to close down and pinch on the wires. If you can't fit the wires in, unscrew these 2 screws and then give it a try. And then once the wires go in, we're going to screw these screws in until they get tight. And you want to make them snug. All right. It is not uncommon for teams to have issues on the field where their robot will reset or turn off and turn back on. And these wires are one of the major causes for that. Another major cause we talked about was when these ring terminals, if they're loose and they can move around, that can be very bad too. All right, so after pushing this back in, we can screw in the top screws so that they stay locked into our roboRio. These ones don't have to be as tight, but tighten them up all the way. All right, now this wire, I think, we're just going to kind of cross over the middle here, and then we're going to plug it right into those connectors where our first fuse is. So I think this is all we need. Let's go ahead and cut these wires down. And then we need to spread them apart. So let me get a little start here, a little trim to start it. We'll peel them apart, so got a little bit of freedom. And then let's strip them again. So this one we want to strip them about as much as the last one should have been. So maybe like that. Say 1/4, 3/8 of an inch, something like that. Okay, and these connectors over here are the same connectors that we used earlier for the CAN wires. They look a little different, but they work the same way. We have to push down on the connector, and then we can put the wire in. So I'm going to push down on the connector. I'll put these into number 20, and then I'll drop the black wire in and let go, and then give it a tug test. Always, always tug test. Red wire next to it, and those two are good. And let's get the rest of that 18 gauge wire that I had. And now we're going to basically do the same thing, but we got to go all the way from the Rev radio power module. So let's get this end split a little bit. I'll pull them apart. If you leave them too much together, sometimes it can be hard to like put the red one in and then the black one in. So that's clearly more than I need for stripping the wires, but it just makes it a little easier to assemble. And same thing. This time we're going to do this connector on both sides. All right, so over here, I'm going to have to push down on this with a screwdriver and then pass the red wire in. Looks good. Tug test. Probably should have done the black one first because that's harder to get to, but we've come this far. That one goes in. Tug. Looks good. And now, I mean, we could just do this with the wire, but I'm going to try to route it a little bit nicer so it stays out of the way. And I think if I go kind of down along the board like this, and I think, let's see, where do we want to pop up? I think I'm going to go under the CAN wires, but I'm going to go over the power wires here. Okay. And that seems pretty good to me. So these can kind of travel together through here. I'll have to like crisscross a little bit. That's okay. And then we need about that much more to be able to connect them. So let's go ahead and cut it. And one more time, we're going to split them and strip them. And with the screwdriver, we're going to do the black wire first because that is on the inside and it's harder to get to. I had one wire get free and it was stopping it. Okay, looks good. Then the red wire. Looks good. Tug test on both. And solid. All right, now we got to go through. We got to secure these wires so we're not going to run into any trouble. And I think one good place to secure these wires are, we can use these motor wires that are coming out because they're pretty sturdy, and we can do a little zip tie around those to help keep everything bundled up. Something like that. All right, and then let's do another one kind of over on the other side of the bridge over here. There we go. Okay, and then this can sort of dive down here and work its way around everything like this. That's pretty good. We want to find somewhere that we can anchor this wire somewhere on this side. And there is a spot on the roboRio here where you might be able to get a zip tie through, although it doesn't feel great. I think what we're going to do with this one is if we drill a couple holes, we can run the zip tie through those holes. So back to the drill. And I think I just want it to be somewhere around here. So make sure I'm not touching the wire or the roboRio. And I'm just going to do 2 holes kind of close together. And let's see. Since this is just wood shavings, we can kind of pretend like it was never here. And then I can pass this zip tie down. Pass it back up from the bottom. There it is. I found it. Okay, and then that will hold it down against our tray there. And you can do more of this. You can add more of these holes and more zip tie points if you want. It never hurts to kind of have a managed electrical board. Loose wires can become a problem. You also might want to wait, though, until you know everything is working before you go crazy with the zip ties. All right, I got a bunch of zip ties to trim. Okay, so this is now powered up. Our next step is going to be we're going to plug in our Ethernet cable from the radio to the radio power and from the radio power to the roboRio. So the roboRio is going to use basically Ethernet, just the same network stuff that we have at home, to communicate with our radio. And what this one does is this adds power to it, so you can actually have those Ethernet cables that deliver power as well. And that's what that one is going to do. It's going to deliver power, so the radio should stay on all the time. All right, let me go find some network cables. All right, I have a couple Ethernet cables. My Ethernet cables are way too long. I think this is a 7-foot one. This one is like a, I don't know, a 25-foot cable. Definitely do not need that much. So what I'm going to do is I'm going to put these in right now so you can see how they connect, but I'm going to try to find a shorter one, at least to replace this one. All right, let's look inside the robot here. So our first cable is going to go from the roboRio. Just plug that in. Make sure it clicks in. The other end then is going to go into the backside of our radio power module here, which we have left ourselves just enough room for. Click that in. All right, and then all of this, I guess, let's just throw a zip tie around it and call it good for now. All right, and we might want to try to zip tie this to something, but I think if I kind of tuck it down here on the side of the roboRio, it's pretty good. On yours, I would recommend zip tying this to something. And I might do that if we swap it out and get our shorter cable. If your cable is short enough, you won't need to attach it to anything because it'll just be held between the two areas. All right? So make sure the roboRio is going into the one that says roboRio. And then the Wi-Fi radio, we're going to plug another one into the Wi-Fi radio. And then on the radio, there are 3 plugs on the back. There are 2 yellow Ethernet ports, and then there is 1 black. It's a barrel jack connector for power. Now, it actually does matter which Ethernet port you use. You want to make sure you plug this in to the one that is next to the black power barrel jack spot. All right, so this has to be all the way on the side like that. Well, no, sorry, in the middle. It's going to be the one that looks like it's in the middle, right? In between the power and the other Ethernet port. That port is more reliable. So that is the port that you are supposed to have it plugged into for it to work. It may work in the other port, but it is a little bit spotty and doesn't always work. All right, right now, I'm going to go ahead and zip tie this to the front of my robot. It is definitely not going to be able to stay here, but until I get a shorter cable, this is the best way for me to kind of keep it out of the way. Oof. And the more I look at it, the more I am positive I'm going to find a shorter cable after this. All right, the entire base of the robot is wired, I think. I believe. So we've got a few more things that we have to wire, though, and that is our two motors that are up on our arm and on the intake. So let's see how we want to do this. I think if we spin this around a little bit, we're going to be working back here on this motor. That's the next one we're going to try to get connected. And this motor is, well, let's see. I talked about trying to turn it so that the wires were in a good position for us, and I'm not sure if they ended up in a good position for us. Because I think the wires would have to come back around the motor and then connect to something over here on their way down. So if we spun this around, it would probably be a little bit better. Now the good news is that's pretty easy, so maybe we'll just go ahead and do that. It is just 2 bolts, so there's this one coming all the way down, this long bolt right here that we can unscrew. And if you don't want to change it, you don't have to. It will still work where it is. And then there's one more bolt 90 degrees around. And you can see the motor at some point here should drop free. Okay, and all I have to do is spin this around 90 degrees. We got to line the hex up, though. And there we go. And now I think we can do it. So you just might have to move some stuff around to get your gears to mesh together and line up. Now remember, with this bolt, we're just going to make it tight and then stop. Do not snug it down. And remember to keep this squished together so there are no gaps in any of these transmission plates. Okay, that is all the way in. What you can do after swapping that, though, is if you move the arm, you should still be able to backdrive it, and it should still sound pretty good as it moves through those positions. All right, so I'm happy with that. We've got this now. And what we need to mount with that is a Spark Max. So we're going to have a Spark Max up here. This time, you can see it does have the 3 wires. So we're going to have to connect all 3 wires together. This will mount somewhere on here, on this frame. And then the rest of the wires we will have to continue down and plug into our power distribution hub on the bottom. All right, so what I think we can do is let's take this wire here. And we haven't worked with this wire yet, but this wire will plug into, if you look at the side on the Spark Max, it says A, B, and C. So we're looking for this A, B, and C side. And the wire, this wire should plug into that A, B, and C side. And there is the little box that's sticking up. That has to go, I think, on top towards the B. Okay, and you just got to kind of push that in all the way. Make sure it goes all the way in. It's a little tricky. It goes in a little bit, and then it stops. Now, this kind of tells us where this can be attached. I don't really want to hang it by that wire, but if we're gentle, it might be okay for a little bit. But the first step here is I'm going to strain relieve these wires. So I don't want them pulling on this. So I'm going to add one zip tie, one longer zip tie, around the motor. And that is going to hold onto those wires, right, so that they will not be kind of straining the connection there. So we'll kind of pull this nice and tight. All right. So we have a little bit of strain relief there. Now then, this is going to kind of jog over and then go down our thing here. And it looks like we can mount this anywhere we want within reason. So probably somewhere around here. I want to make sure that these wires overlap a little bit. So when we use our Wago connectors, it goes on easily. So I think I'm going to try to attach mine somewhere around here. And what I'm going to do is I'm going to put a little mark on the bottom of it and a little mark on the top, so I can find my position again when I come back in. And I am a huge fan of the Velcro plus zip tie combo, so I'm going to cut another piece of Velcro for this SparkMax, just like we did on the main board. Seems like we need about that much. All right, stick them together. We're peeling the fuzzy side. The fuzzy side is going to go onto our device as usual. Get that squeezed on there, right? And now I'm going to come back to that mark that I was happy with, and anywhere close to that mark is going to be just fine. And I'm going to squeeze this on. When you do this, don't be right on the very back because you want kind of the frame to take the hits first. In fact, maybe you want to have it towards the inside, but you could get hit this way too. So I'm kind of trying to center it here so it's relatively protected. And then we are going to take our zip ties. And remember, there are those zip tie channels on it that we can run through. And then we are just going to bring this tight. And I'll do one on the top, and I'll do one on the bottom. Does the shorter one reach? No. Okay, get it in those little grooves and pull it tight. All right, this is definitely not going anywhere. Let's trim our zip ties here. All right, and then we can connect our, oh no. Let's cut the zip ties off. We need to make sure that the red, white, and black side, oh no, I got it right. I thought I had it upside down. I didn't see the white wire. All right, zip ties go back on. And then we're going to start stripping and cutting the wires just like we did before, and we'll connect them together with the Wago tools, with the Wago lever nuts, sorry. So get these on. And snip them. All right, and now we have to strip all three of these and all three of these. And we're back to like that 1/2 inch length that works well with the lever nuts. Could be a little less probably. Okay, those three are good. Now we're going to do these three. And there is a label on here. These ones are brushless motors. You can't just connect a battery to them and have them work. So our motors in the base, those sim motors that are drive motors, you could just plug a battery into. But these ones actually need a little bit more sophisticated control than that. So plugging a battery directly into them is not a good idea. All right, let's get them connected together. Also, that's why there are 3 wires there instead of 2. All right, lever nuts. We can go in whatever order. I guess I grabbed the red one first, so we'll start there. Make sure it's in all the way. Lock it in. Give it a tug. Red one on the other side. Got a couple of loose strands there. All the way in. Snap it, tug it. Moving on. I'll do the black wire next. Looks good, looks good. That'll do. Yes, and last white wire. All right, tugs all around. It's good. Okay, and all I really want to do now is these wires. We kind of have our little loop here. Perfect. based on where we put this. So just one more zip tie around all of this should hold those wires, keep them out of trouble. Yeah, looks good to me. Snip this one, snip this one. All right, now on the bottom, we're going to end up running these back down to our frame. And then we're going to have to get our CAN wires connected up. And if you remember, in the frame, we had one CAN wire that was just kind of still hanging out that we haven't connected to anything. That one needs to connect to this one. And they don't reach. We're going to have to do something about that. All right. But first, we'll go ahead and hook these into our power distribution hub down on the bottom of our robot. So let's bring back the 12-gauge wire, our thicker, heavier duty wire here. And I dropped the robot signal light. OK. And we'll just go ahead and strip this end here on our Spark Max. And then we're going to split and strip one end of our 12-gauge wire again. Two more lever nuts. I'll start up here. Red one is good. Other side gets the red one as well. And this time, remember earlier I said, hey, if you flip the leads going to the motor, it changes the direction the motor is going. But for the brushless motor or three-phase motor, you got to make sure those colors match up. I did say with the Sims, if you flip them, they just go backwards. But here, make sure you get all the colors matched up. And on the power side, which is what we're doing now, everything always has to match up or we're sending the wrong voltage into the motor controller, and it's not going to want that. All right, black wire, good. Other side, also good. All right, so these are going to have to run down, jump over inside the frame of the robot here. And then we're going to kind of go maybe around the battery this way until we can use any of these ports we want, so we might as well use the first one. All right, so somewhere around here. We can always trim it a little more if we need to afterwards. No problem. OK. And we're going to split them and strip them. Pull it apart. And I guess before I strip it, let's just make sure we're happy with this. So we can get a zip tie somewhere around here, maybe somewhere here, and then another zip tie there. And then we'll kind of duck down into the frame like this. So we're going to have one here, one here. This goes down. Oh, this is way long. All right. So let's see. Well, we also kind of want to get let's do it. Let's just zip tie these as we go so we're sure it's in the right spot. And then what we'll do when we run the CAN wire is we'll do smaller zip ties to these wires. So first thing is I'm going to get ones just above the connector here. That looks good. And then on the other side here, I'm going to get a zip tie kind of around this to hold it in place. I'm going to go to the front. I'm going to go to this hole. You need to be very careful with this one because either we go this way and it's kind of really close to the edge of the robot, or we go this way and we're getting close to the wheel. I think we have enough room, but you just have to be careful here when you put this one in to make sure that you have the clearance around the wheel after it's all tightened. All right, and that looks clear. That looks like there's plenty of room. Good. And good. All right, then we can dive down this way, run across the board, pop out, and plug them in. And so these are probably long by about that much. So let's trim them down a tiny bit here. And make sure you have enough left over that you don't have to trim it to be able to split them again. And now we're ready to strip these wires. All right, and we'll feed it back down. I'm going to go in port number 1 looks a little bit easier for me to reach, so I'm going to do 1 instead of 0, but you can do 0 if you want. And we're just going to feed the black wire in, close it, tug, didn't work, try again, black wire in, close it, tug, that's good. And then the red wire follows suit. Okay, that wasn't even remotely close to the right spot. I put it in 2 instead of in 1. Right. That's fine. Into 1 we go. Lock it in, tug, that's good. All right, and then let's look for a place, one more place at least, where we can kind of zip tie this to keep it out of the way. And I kind of like the main battery cable here, because that's a big heavy-duty cable that's not moving around a lot. Use a smaller zip tie this time, though. And we'll just kind of go around, I don't know, around here somewhere. Smaller hands would have the advantage here. All right, but we got it. And we'll just kind of pull that one tight. So you can see that wire is pretty well constrained everywhere it's going to go. It is clear of where the battery is going to drop down, so that's also nice. We don't have to worry about smashing our wires with the battery. And let's go ahead and trim that last zip tie. All right, now our next trick. This CAN wire has got to get all the way over to this one. And I think the only way we're really going to be able to do that is by adding more wire. All right, and I think I'm going to kind of route this one maybe over to this side, and we can meet up somewhere. We'll go through the middle because everything else is going through the middle, yeah? And so we need to get to somewhere there. And remember that one PWM cable we cut earlier. And we cut that PWM cable earlier to attach here. So we could use that, although when we get to this side, we're still going to need an end. So I wonder if what we want to really do here is to get another PWM cable. And so this is another 3-foot long one. This one's going to be too long, but it's going to save us a little bit of wiring. So that's fine. If you wanted to, you could cut this end off, which I don't like because they work so well together, right, when all your speed controllers are together. So I don't really want to cut this end off, but you could cut this end off, cut the end off over here, and then just Wago lever nut some wires together. But these ones will reach with just this PWM cable, so let's do that. So I'm going to bring this in, and we are looking for, I'm going to always do green to black, white to red when I do these. Always, always. So we'll plug that one in. All right, and then this needs to go all the way up to the wires coming off of our Spark Max up here. And again, green to black, yellow to white. Okay, and now we can route this. We're going to have some extra wire that we can find a place to bundle up. That's okay. And then our last problem is that we only have 2 more of these clips to hold these together. So when you run out of these clips, so if we use both of them here, we are going to need another clip here and another clip up at our top motor in order to have everything connected the way we want it. So when we run out of the clips, we are going to use electrical tape to hold it together. Is usually the best way to do it. So on these ones, since they're pretty secure, they're in like pretty safe spots, I think maybe we'll use the electrical tape, and we'll save these two for the higher up positions. One here going up, and then one at the top coming back down. So let me grab some electrical tape. So it happens I don't know where it is. All right. Okay. Okay, and just gonna, let me get a nice clean edge here. I think the last time I didn't do such a great job. And we'll take some of this electrical tape and cut it off. I'm gonna use a little bit of a longer piece than you might think I need. But what we'll do is find the connection here, make sure the tape is going over the connection, get it squeezed on really nicely, and we're gonna go around a few times. And then when I get towards the end like this, I'm not going to keep going. I'm going to fold down a little tag on here. So when I finish, I have a good like peel to take them apart in case I ever need to. Sometimes being able to do stuff quickly at the competition is important. And give it a little bit of a tug. It's not going anywhere. And we're going to guarantee this is good by our zip ties that we're about to add. So let's do those now. We'll get some of our tiny zip ties here. And so this one, where do I want this to be? I kind of want this connector to be in between where the other connector is. So we'll have a little bit of extra of this wire up top. Okay. And what I'm going to look to do is I'm going to zip tie this just to the other wires. That is going to be fine. And I'm going to zip tie this on. And I want to be close to the connector, because if we zip tie it close to the connector, that is going to be another way that the connector is not going to be able to disconnect, right? If it's anchored and it can't move around, it can't unplug. And I'll just kind of take some of that extra wire that we had and get it down nearby the connector as well. And we'll zip tie that in. And then we're going to zip tie right on the other side after the connector. All right, and now we're just going to kind of follow the other wires down into the frame of the robot. So I'll throw another zip tie on somewhere over here. Okay, and how do we want to travel through this area? I think what I want to do is I'm going to split these apart for a second so I can pass this. I'm going to go underneath the battery wires here. We'll run kind of down in this channel underneath those battery wires. And then we'll dip underneath the red one here too. And we'll work our way over to join the bridge of wires that we already have going forward and backwards on the robot, or crossing the middle of the robot. So I'll do another zip tie. Maybe on this one, I'll grab onto this red wire that's here. Seems like a good spot for another zip tie. Okay. We could put another one down here. I'll skip that one for now. Okay, we're going to come over to our little bridge here, and we'll add a few zip ties as we cross the bridge. And let's get one on the other side of that bridge. All right. Now that we're over here, let's plug these back together. So white to yellow, green to black. White to yellow, green to black. And let's do the tape again. The electrical tape. Make sure it's all the way in. And make sure that first layer is tight. I'm actually stretching it a little bit as I try to wrap it around the first time. So that'll give it a little bit more grip. When I get towards the end, I will fold the little tag on just so, you know, if there's an issue, it's going to be much faster to get in there and fix it. Good. Now, all the rest of this, we need to just bundle up so it doesn't get in the way. That is one benefit to if we had cut the CAN wires and done a custom length cable. We wouldn't have some of these extra bundles. But some of this is just like, hey, cutting less wires is nice, but also preserving the wires for the future is sometimes nice as well, because we don't know what next year's robot's going to bring and how much of this stuff will need to be reused. All right, so I'm just going to look to get a couple zip ties here to hold it to kind of these bigger wires and keep our bundle nice and flat out of the way. Looks good. And then I'll do one more on the other side. Perfect. All right, trimming all of the zip tie ends now. Okay, wait. Now we're okay. All right, that motor is done. And so the only thing we have left is our top motor that is on the intake and the return CAN lines that are going to go into our PDH. I think in order to work on that motor, though, it's much higher up, and I'm going to have to move the arm. So I'm going to kind of clear this all out, just get the parts I need, and probably come back with the robot on the floor to finish up our wiring. All right, time to start working on this Neo 550 out here on our intake. So we need our last Spark Max controller. And I don't know, we just got to find a place around somewhere here where we're comfortable with it. So the wires are kind of this long, but I don't think I want to put it on top. I think if we put it on the inside here, let's see, as the arm moves, that seems safe and protected. And when it's sticking out, if other robots collide with this, that also seems like the best place. Here is also good. Although that gets a little closer to the frame than I want. So I think I'm going to go with the inside here, and we should be all right. So we're going to mount this the same way we mounted the other ones. We'll start with a bit of Velcro, and then we'll back that up with some zip ties. And fuzzy side on the device. I feel like all of you probably remember that by now, but that me repeating it is as much for my benefit as it is for yours. Okay. So the wires are going to have to probably go up and over this area, and then we'll have to do a little loop here. So I think somewhere around here is good. I do want to kind of try to be clear of this bracket in case this T-gusset needs to be removed. So I don't be right on it. So we'll go somewhere about there. That feels pretty good. And let's get a couple zip ties. This one especially, like the ones that are sitting down on the belly pan in the robot, like they have nowhere to go. This one, if it falls off, it's more of a problem. So for sure we want to get these zip ties on here. All right, that's not going anywhere. Next step, we can take this wire, the I guess control wire, signal wire here, and remember it goes on the ABC side, so we're going to plug that into the ABC, underneath ABC. And Also, make sure you have the red, black, and white wires facing each other, and the other side should be the CAN wires and just the red and black wires. Let's make sure we get this plugged in all the way. All right, there we go. And now we're going to start stripping wires, and we are going to use the Wago lever nuts again. So we'll strip all of these. And all of these. All right, back to our bag of lever nuts here. And again, it doesn't matter what order you do it, just make sure the colors match. And make sure you do the tug test. I got some wires that didn't go in. That's not good. So try to make sure that none of the wires fold back on it. Looks good. White to white. And red to red. Okay, and then we definitely don't want these wires going all wild like this. So we're going to look at kind of making a little bundle here and zip tying them up. So I'll do one here. And maybe, let's see. Do here. I think we can do one more bundle right there. If you needed to, you could put a hole in the polycarbonate here. And they also sell there are these little sticky things that you can stick on that are tie wrap anchors or zip tie anchors, and you could use that as well if you can't quite get this in exactly the right spot. Okay, that one's too far. I'm getting a new one. All right, so those wires aren't going anywhere. Our next step, then, we're going to run the power wires and the CAN wires back down. So I think this is enough wire left. You want a decently large spool here. Let's go ahead and strip the power wires. And then I'm going to use the rest of this. I think I started the whole robot with this as 25 feet, which I think is what you get in the kit of parts. So we should both have enough to finish this up. Let's split this one and then strip it. All right, red to red. Okay. Let's see. we'll do just the power wires, and then we'll go back and figure our CAN wires out. All right, so the first thing is when we get to a junction like this, we are going to want to have this anchored down. And how folded up does this get? Okay. So it seems like we probably want to anchor these down just a little bit back from the pivot point here. So the idea is because everywhere that we end up with a pivot point, the length of the wire is going to change just a little bit. And so I think if we strap these on the inside, we want the wire to run as close to the actual point where it pivots as possible, because that is where the distance changes the least. So I will strap these up right on top of my hinge right here. Well, right next to the hinge, but I'll put the zip tie right over the top of the hinge there. And what I like to do to figure this stuff out is, now that this is anchored, and maybe I'll put another one on the other side at some point, if I hold this where I think I want the other end to be, then I can move it through the motion and see if it's working. And so my thought is, if I anchor it somewhere here, I'm going to leave just a little bit of slack in this position. This is basically all the way out, but if our stop changes, the arm can go a little bit farther, right? So I want to just leave a little bit of a bump there. And if I hold on to this, as we put the arm back, I guess I have to reach from this side. As we put the arm back, we'll see if that loop gets into any trouble or if it is able to kind of stay nice and tidy the whole time. So that's looking good. So I think that's where I'm going to anchor this one. We'll get right up kind of as close as we can here. It was just about, I guess we could probably get this on the inside here, and that should be fine too. So now that that is anchored, let's move it again. Oh yeah, that's working. We have enough slack there. Perfect. Then we're going to route this. Let's see. Where do we need to get? So eventually, I guess if we stay on the inside of the arm here, we would either have to leave a loop kind of this way, going underneath. And what happens to that if we move the arm? That gets very, very tight. All right, so what if instead, I see. What if we aimed to a point like this? So if we went on top of that box to here, let's try it. So that looks pretty good. That looks like, I think, what I want to do. As we wind it a couple times through there. Yeah. So I think that's the side we want to be on. So we're going to route this up the arm. And the key is, at the end of this, I want to be up here on top. And I want my anchor to sort of be as close to this bearing block as we can get. So that seems good. And again, it never really hurts to have some extra ones in the middle. So putting more zip ties on than I have is probably a good thing, especially once you know it works. All right. Then the other side of this, right, we want it to be attached kind of here. I guess we probably want to be on the inside like that. So let's go ahead and anchor that on and see how it looks. So before I tighten that down, I can control the length of the loop still. So let me bring this back and make sure I have enough. I want a little bit more, actually. It gets a little tight on me at the end, so just pass a little bit more through here. And it looks like my loop goes from where I have it clamped, the loop end goes basically up until it hits that top frame member. And then we want to get this nice and tight so it doesn't move around. And if it doesn't feel super secure on there, you can always throw a second zip tie on to try to help out. Because we really don't want this area to shift around much. We want it to be pretty static. And one of the things you want to try when you're doing these zip ties, if you can line the end up with the corner, that usually means that it's going to sit a little bit tighter and a little bit flatter. The other thing you can do too is if it really is not getting tight enough to hold the wire, I think mine is feeling pretty good, but if it's not, you can add more stuff. You can wrap the wire in some tape so it's a little bit bulkier, so when you crank down on the zip tie, it has more to bite into. All right, then we have to make a decision with how we want to get through this corner area here. And it looks like either we need to dip below, which looks correct, or we have to ride on top of the frame. And I think underneath makes more sense. So let me bring all of my other wire back this way. Okay. And then we're going to try to go basically along the bottom of the frame like this. All right, and let's get the zip tie on the other side. It's just like wiring the robot is just a lot of like slow, tedious stuff like this. But you want to take your time and make sure everything is nice and clean because we'll save you from problems later. All right, we'll take the rest of this wire. And then I think what we want to do is run on the inside of the frame at this point because that's a little safer. We don't want to run where the chain is, so I think that's why. If we bring it up to the inside here, that's going to be good for us. And we'll go all the way on the inside of the frame until, well, do we want to be, how close does this get when we're on the inside? I guess it's okay. Yeah, just make sure there's not a lot of it sticking out, and we're going to come basically above the bracket that's here. We have to ride along that wall. Are these ones long enough? They are just barely long enough. Cool. All right, and then somewhere around the end of the chain here, somewhere around this T bracket, we are going to start to dip underneath again. So that we can come down along this piece here. And sort of as we come down to the bottom of this tube, then we want to move to the inside so we can get over to, and kind of get around the wheel safely. Okay, and then we'll run it from there. Then we can drop down into the frame and find a place to plug it into our power distribution panel. I'm going to do this one on the frame here because I really don't want it to move towards the wheel at all. All right, then if this dips down here where it's nice and safe, let's figure out how much wire we need. Remembering that we will have to go around the battery. And that seems pretty good right about there. So let's cut it. Strip it, split it and strip it. And then lift the levers up, make sure we get red into red and black into black in here. Okay, do not skip the tug test. And that is looking pretty good. And remember, you can use any spot on the power distribution hub that you want. Now, while we're down here, we need 2 more of these 40 amp breakers. And we need to get them into, so you have to find on your power distribution hub, right, the places that we plugged this one in, which we just did, so we know where that is. It's right here. And also, we have to find the port where we plugged it in, our other motor in, right? So we just plugged this one in here. Then our other motor was in port number 1, or wherever you have your other wires coming in. Get another one of those 40 amp breakers and drop it in. So now, we got to wiggle those a bit. So now we have 6 40 amp breakers in here, and they should line up with all 6 of our pairs of wires. Okay, so that is all of the power done. Now we got to go back up, and we got to figure out how to route our CAN lines. Okay. So on here, we've got our 2 wire ends. And I think we got these 36-inch CAN wires. I don't know if they're going to be long enough. Let's see. If we use one of these 3-color PWM cables here, that's the one we already cut an end off of. If we used one of these, so let's go ahead and plug one of these in, where it's always black to green and white to yellow. If we did this, let's kind of follow along. I'm just going to kind of guide this along where the other wire is running. And the question is, how far can we get? So that would get us to like here. Then, if we use this 36-inch long piece, that is going to get us, I think, where we need to go. I think it's going to work. All right, so let's do that. So up here, we're going to plug in 2 of these onto our 2 sets of CAN wires. Again, white to yellow and black to green. And this seems like a good spot to use our last 2 clips that we can put on just to keep it from falling apart. Okay. And the good news is it doesn't really matter which CAN wire goes where. So we don't have to actually pay attention to which wire is which. If we did care, what we could do is we could label the ends with a little piece of tape and write down which wire it was. But these wires will work in either direction. So now we're just going to route this along where the other wire is going as far as we can. And this time I'll use the tiny zip ties, and I'll just attach them to our bigger wires that are also running through here. do one more here just so that they stay together like a little bundle. All right, once you get through the first joint, don't forget you got to swing it through its motion and make sure nothing bad is happening. That looks good, so we're ready to carry on to the next step or the next area. And we want to match the loop here as well because we know that loop was big enough. Might have wanted to cut the zip tie ends. They're kind of all over the place now. Makes life a little more difficult, but just pulled that one a little too tight. All right. All right, and now both of those we have to connect to something else. And that is going to be, we have two of these 36-inch long CAN cables, or yellow and green wire pairs here. So we're going to have to cut off the ends of the wires that we have. And we need most of that wire, so we have kind of room here to reconnect it. So I'm going to trim a little bit. I'm going to try to save like, I don't know, maybe 1.5 inches or something on these, because then we could use these as connectors on the other side if we need to. And then we need to split these. Remember, we're not using the red wire, so you could trim it back if you want. In fact, if you really want to save weight, you could take this entire red wire out of the whole thing because, again, we're not using it. And let's go ahead and strip these wires. And then we'll add some more lever nuts here. Okay. I think I should strip this one a little bit more. That's better. They both passed the tug test, though. Then I'm going to take one of these CAN wires. White is yellow. Tug looks good. And black is green. Tug looks good. All right, so that's one line. Now we're going to do the same thing on this other set of wires we have poking through here. So I'm going to spread them out. Trim the red wire back just so it doesn't get in the way. Let's trim this one. All right, 2 more. Think about all the time we've saved not having to solder all these wires together or make connectors and crimp them on. All right, and then this one gets our second 36-inch long CAN cable here. And if you don't have these CAN cables specifically, you can use any white and green wire. You can just go to the store and pick up some white and green wire, or sorry, yellow and green wire, and that will work fine too. All right, and I'm doing white to yellow, green to black, as always. Tug test looks good. All right, so these are ready to keep going now. So we definitely want to get a zip tie right after the connectors. And we want to make sure those connectors stay, we really want to manage them. We don't want them to be in too far, because remember this arm swings back, so we don't want them inside. And we got the chain right here, so we don't want them outside. So we really want to get them nicely right kind of on the bottom of this beam. And that looks good. And now we're just going to keep going, following the wires we already routed. All right, and this is where we have to kind of split them up. So one pair we're going to be taking back to try to plug in. Oh man, and we just barely can't reach. That is unfortunate. All right. Well, so it goes. All right, and so one of them is going to go back to the power distribution hub over here, where we're going to plug it into the yellow and green CAN wire spot. I am like 2 inches short, which is a little sad, but I guess we can take a different route then. The other one has to plug into our other Spark Max that was up here. So we're going to need to plug these two together. And they're also a little bit short, but we need a different end on this anyway, so that is going to work out just fine for us. I think we have the other end of this cable. So we cut this cable a while ago in order to plug it in here into the roboRio. So this end actually is perfect to plug into the other wire we have on our Spark Max here. So we can plug that in white to yellow, black to green. And then we can kind of decide, I guess really, if we come down this way, we can have everybody join up in the same place. Or we could run these wires kind of along the inside of our frame here. And I kind of like that. Maybe I don't like that. If we get it far enough in, then the battery won't hit. But I think it's safer to go this way, so let's just go this way. So I guess we keep routing these two wires together. We'll come down into the robot over here. All right, and on one of them, so now we have this end that we just made. This we can start routing down the other direction. So we can throw another zip tie around this bundle. that. We have the connection here, and as we did before, we're going to tape that connection up so it doesn't fall apart. So I'll get a bit of electrical tape here. And I'm going to do the little tag so I can take it off easily later. All right. And we keep going. Okay. I think if we go on this side of our power cable, add another zip tie down here maybe, and then we can run along this edge of the power distribution hub. And get the last connections together here. Okay. So then we can pick whichever one of these wires we want, and we are going to connect these two together. I'll leave myself some extra slack, but we are going to cut here, and then we'll strip the wires, and we'll use some more Wago lever nuts. So somewhere around here is probably good. All right, white, tug test to green, or to yellow, white to yellow. And the black wire, tug tested to green. Perfect. All right, so these are good. And this can just kind of get wherever we want. We can add one more zip tie to hold the excess down here. Attach it to one of those wires. Okay, and this is just because we want to make sure it doesn't go inside the battery area. We don't want to put the battery in and smash it. Then we've got this wire, which needs to get over to here. And we can just probably use the bit I cut off of this. If you have more green and yellow wire, though, you can use that as well. So I think we actually grabbed a long, so 25-foot cable. So this one would have made it all the way on its own. But so we can use this to get the rest of the way. Again, if you don't have any other wires, you should have a little bit less left of this PWM cable that we can use, or the 3-color cable. But we just need to add a little bit more to this. So we'll go ahead and strip these wires. And add another connector to them. So if you're using the red, white, and black cable, make sure you do green to black. If you're using another yellow and green wires, then of course make sure yellow matches yellow and green matches green. All right, tug test, that looks good. And we'll kind of like route this wire in so we know where it's going. It's going to go along here. Really, I probably want to go under that and then leave myself enough room to plug it in. So somewhere right around here seems good. Okay, and then I will, well, let's strip the wires first because that's easier right now. Okay, and then I'm going to route this. I'm going to go underneath the power wire here, I think. Okay. And I think we can use whichever of the can spots we want, but we have to push down on that with a screwdriver. Here's my screwdriver. So we'll push this one down, slide the green wire in, and push this one down and slide the yellow wire in. Tug test, they both look good. So, see, probably one or two more zip ties here, just to make sure this wire can't get stuck in the battery, and then we are done with this wire. All right. So that is all of our motor wires now connected. We've got all of our can connected and all of our motor power. We have one more device that has to get attached to the robot, and that is our robot signal light. So this basically helps diagnose the robot. So it'll flash with different color patterns. But we need to figure out somewhere to mount this, and this plugs into the roboRio. So I'm thinking somewhere in this area is going to be the best. So first of all, we can use this 2-wire jumper cable that is just red and black wires that I believe came in the kit of parts. And this 2-wire is exactly what we need to plug into the roboRio. The other end, though, we're going to have to do something to connect it to our robot signal light. So that's the wire we're going to need. Let's set that down. Then we need some way to mount this. And the way that this mounts is there's a little plug that you can take off the bottom. And then there is a kind of a nut here. And so the stem is threaded. And if you have a hole that this can fit through, then on the other end, right, we can tighten this nut up, and that will hold it in a position. I don't see anywhere on the robot, though, that we can just drill a hole. I think, like this bar here, is just a little bit too thick, so it won't fit through, it won't reach the other side. So it's a little difficult to do it on this bar. But we have some of these cutoffs from earlier when we were building our chassis. Remember the, I don't know, Z-shaped cutoff? So this one is nice because we can drill a hole on this surface. This will mount to it. And then we have a couple of holes ready, and we can choose where we want to put this on our robot or rivet this to the robot. And so I'm thinking somewhere in this corner. I kind of like the idea of riveting this onto the side here, and then the light will be sticking out forward. And I think as long as we stay below this crossbeam, we are in a just fine spot. So probably somewhere around here, I think, is what I would do. So in order to do this, the first step, though, is we're going to have to take this over to the drill press, and we're going to have to make a hole big enough for the light to fit inside. All right, so the first thing we have to do is, if I measure just the stem part, the screw part on our robot signal light, I get 0.86, 0.859. So that means we need to do a 0.875 or a little bit bigger hole. And the only thing I have that can make a hole that big is our step drill bit again. So if we kind of clear this off, we can see. So that first line is 7/8 of an inch. So the first white line on mine is 7/8 of an inch, and that is 0.875. So it should hopefully fit the the robot signal light. So let's add this to the drill press. You could do this by clamping the piece up and using the hand drill. It's a little faster in the drill press when you're using the big step drill bit, though. So I think in order for me to drill where I want, I'm basically going to eyeball it for the middle of the piece. But to clamp this up, if I'm over here, I think I'll have to drill into my vise to drill in the middle of the piece. So I'm going to end up clamping this up a little bit, which means what I really want to do is I want to find something to put under the other side in order to keep it level. Or if you're good, if you keep this side flat, you can kind of eyeball the level. Again, this hole is not super important. So I think that's going to work. And then we just need to line it up so it will go through the hole on the bottom of the vise here. And again, this one doesn't have to be precise. So after all of the other work we did on the robot where we had to make everything exactly right, this one we can just kind of put wherever we want. That looks pretty good. I will use a drop of oil here for it. And remember, with this, you want your slowest possible speed. All right. That cut nicely. We got a lot of these long, stringy things. All right, so the question is, does the light fit in there? And I think the easiest way is I'll undo this and slide it out, and we'll see. Yep, drops in no problem. So I am done here. I'm going to unclamp this, clean up the area, and then we'll be back at the robot to mount it. All right, so we have our piece, and we can put the light in it, and we can either attach it this way, or we can attach it this way. It doesn't really make a difference. I think I'm going to attach it this way, just because I think it'll be easier to rivet these when you can see. That's the only reason I'm choosing to go in this direction. But you can see the light fits in there nicely. I'm going to take the light out, though, so it's not in the way when we are drilling. So this, really, like I said, anywhere around here is fine. We could be up tight to this bar or down a little bit. I think I'm going to go just below these gussets, just in case we have to work on those gussets. It's not going to kind of be in the way, causing any problems. And once you find a good spot for this, we just need to clamp it in place, and then we're going to drill and rivet. And what I'm going to do is, again, it doesn't really matter as long as the rivets can go in, but just because I think it's going to look the best and protect the light the most, I'm going to line up my plate with the back of this bar so the light will sit a little bit farther back and be less likely to get hit. But again, I mean, really, you can put this anywhere on here, and it's going to be just fine. You could even turn it a lot so the light was more straight up and down if you prefer. But I do want to try to get a second clamp on here. And then, after this clamp goes on, we are going to need the most important tool, if you can call it a tool. I am about to drill on the robot, and all of the electronics are now in the robot. So if I just go ahead and drill, and some of those shavings get into the roboRio, we would be in for a world of hurt. So I have an extra shirt here. This is probably not the shirt I would have used, but it is the extra shirt I have today. And you can use anything for this. You could get a tarp, a drop cloth, but I am going to cover up all of the electronic stuff over here. And we're only drilling a couple small holes, so I'm not too worried about this back section, but it's never a bad idea to just cover everything. So a nice big hoodie would work well. A couple shirts would work well. But I think we're safe enough to go ahead and drill this hole. You can see all of the shavings that we are slowly collecting here. All right, and we'll rivet this in. Go ahead and use the hand riveter for this one. And then we'll kind of move this clamp up as high as we can, and then take the bottom clamp off and do the bottom rivet. And yeah, my drill is hitting this bracket, so the drill is going in a little bit crooked. But for rivets, when we're just going through a little bit of material like that, that is just fine. All right, and we'll go ahead and rivet this one in. Okay, I'm going to undo the clamp. The next step is make sure you brush off any extra shavings or stuff that's there. And then you can see we've collected all the shavings on top of our shirt. I'm going to very, very carefully remove this shirt. I don't want it to drop any of those shavings, especially onto the electronics area. So you kind of can bundle it up like this and pull it out. You can shake the shirt out and save it for later. All right, so now this is mounted securely enough because it's just electronics. Let's take our robot signal light, put it in, and then on the back side, I'm just going to screw in this nut. And the nut, I guess if you look really carefully, there's a smooth side and a side with ridges. The smooth side should be up towards the metal. And that is a mounted robot signal light. All right. Let me get rid of the power tools, and then we'll wire this one up. All right, so we're going to wire that light in. One thing I'm going to fix, though, is I have this massively too long Ethernet cable here. I'm going to go ahead and replace that because we did find a short one. And that's going to make life easier when we try to route this other wire down, not to have to deal with that huge cable. So this one will tuck nicely down inside the frame. Perfect. And I probably will go back in and add a zip tie to this at some point, but it's not going anywhere bad right now. Much better. Then, okay, we have our connector here. And this is kind of a weird connector. It's got LA, N, and LB. And we have to wire this up in a little bit of a funny way. So we actually are going to connect LB and LA. And then this wire can just plug into LA and N, N being kind of like our neutral. So we'll do the black wire into N, the red wire into LA, but we need an extra jumper wire that goes across from one side to the other. So we will start by taking our cable here. And you can just see, if we plug this in where it goes, there is a spot on the roboRio that's marked RSL, which stands for Robot Signal Light. And it has two things next to it. It has the letter S, and then what looks like, I don't know, what does that look like? It's like a top or an arrow pointing to the side. So that top or arrow shape, that is the symbol for ground, and S stands for the signal line. So we know black is going to go into the ground side, and then red is going to be our signal. And then this wire, really, we're just going to kind of run it over this way, and then just come up here and plug in. So we really only need about this much of the wire. So I'm going to go ahead and cut it there. And then we need that extra bit of red wire. So if you don't have any other small red wire, what we can actually do is take a little section of this. I'm going to cut about, I would say, 1.5 inches of these wires. And we really only need the red side. So then I'm going to try to split them apart, peel them apart, so I just have the little red side. OK, and we're going to strip both ends of the red side of this wire a little bit. Looks good. I'm going to set that on the roboRio so I don't lose it. Then the other two wires that are coming up, we are also going to split those apart and strip them as well. Now these are ready to go into our connector, but to tighten this connector, we need another flathead screwdriver. So let me grab that again. And the first thing we're going to do is I am going to sort of unscrew them to make sure there is room for the wires to go in. So I'm just going to unscrew, and you can see, you can watch as you screw it in and unscrew it, the little there are little jaws inside that open and close. So we just want to make sure they're open enough that we can fit our wires in. And then I am going to take the short red wire that we made, put that into LB, and then I'm going to go ahead and clamp down on it. Make sure it's tight enough. You can give it a tug test. It shouldn't go anywhere. Okay, and then, actually, I think I'm going to bring that out just a tiny bit. You want to make sure that you're not really clamping on the insulation, but that you're clamping on just the wire part. So that looks good. Then we're going to bend this around and stick the other end into LA. And if you have a hard time doing that, just go ahead and cut yourself a longer wire. The longer the wire is, the easier it gets. But before we tighten down LA, we're also going to take the wires that we plugged into the roboRio, get the red wire, and put that also into the LA spot. So we have two different red wires going in there. And once those two wires are both in there, then go ahead and screw that screw in until it is nice and tight. Okay, then we just have the last wire, the black wire. Do the tug test, of course. Then the black wire goes into the N spot. Tighten that up, our neutral port. Tug test on that one too. If you do these tug tests and you pass all the tug tests, that's going to solve probably half or more, maybe 75% of the electrical problems that you would have had during the season. All right, then this will just plug into the back of our robot signal light. And it only fits one way, and it is apparently this way. Second try. Okay, and then really what I want to do is just get one maybe zip tie down to something in here. We could go to the frame here maybe. But I think I've got these wires that are right there, so I'm just going to do one zip tie to that so that this wire doesn't get, I don't know, out into the drivetrain or anything. All right, and that's good. Okay, one more thing that we can do while I am here, and that is we had this wrong strap for the battery connector, and I have now found the right strap. So I'm going to loosen this up. You don't have to do this if you got your battery strap connected correctly. If you're not sure if your battery strap was connected correctly, then I will now do it, and you can see if we match. So I'm going to loosen these up. I'm going to take out my Velcro strap, which will work if that's all you have. And then this is the official battery strap here. Okay, and one end sort of has this point. That's what's going to go down through here and come back around to tighten on the battery. The other end, we've got this little buckle. I'm actually going to fold the buckle. We don't really need the buckle, I guess, is what I'm trying to say. So we just have to figure out where we want that buckle to end up. So I'm going to loosen these up a little bit more. There we go. I think if I can get the buckle, I definitely want the fuzzy side of the Velcro facing up. And if I can get the buckle under this, that's probably like the best situation here. So that's what I'm going to do. I'm going to take the buckle, fold it back under, and then bring this back underneath the little clamping plate that's here. And then go ahead and get this bolt started as well. All right, and I'm leaving sort of the end of the buckle and the end of the connector out past it. And then we're just going to tighten these down. And the plate basically should bend around it as needed to be able to sort of clamp everything in nice and tightly. All right, and you can also tug test on this. That's not going anywhere. So we're in good shape there. We have one more thing to do, and that is I'm going to show you how to wire up a battery. Then we can put the battery in and try turning the robot on. Okay, so I've got my battery, and we've also got, and there are a few different legal batteries, so yours might look a little bit different. Don't worry about it as long as it is on the list. I mean, you would have gotten them in your kit of parts, so you'll know they're good. And the battery should have some of these little hardware packs. And I can't remember, because my battery is old, if they come, I think they come disassembled like this. So we're going to look at grabbing the pieces we need. There are, of course, 2 bolts and 2 nuts that are going to kind of be on the ends, tightening everything on. Then we have regular washers, and then we have this split washer again. I think we had one of those split washers earlier. And then I've got the battery cable here. So the idea is, well, we have a red wire, and we have a red side and a plus on the battery. That is the positive side. Then we have the black section and the negative sign, and that is for the black wire. And the way we're going to do this is we're going to start with a bolt, put a washer on it. The washer then goes through. It doesn't really matter which way you do these, and mine are a little bent. Yours hopefully are nice and straight. But we're going to go through that with the washer. Then we're going to slide that through the terminal on the battery here. Okay. You don't have to be super scared of the battery. Even if you touch both sides, your resistance is high enough that this battery is not going to shock you or hurt you. Now, if you get metal touching both sides, you're going to have a problem. So you don't have to be scared when you're doing this. Just be wary. Don't have anything metal connecting both of those ends. All right, so we have this one on. Then after that, we're going to do another regular washer. Then we're going to do the split washer, and then the nut. And it doesn't really matter if this bolt is going this way or this way. I like to do it this way because there's a little bit more space for the extra pieces that are there and the extra bit that's sticking out. All right, so that is on, but it's not tight yet. And I'll go ahead and get the other side started, kind of in the same way. So it's going to be a bolt and then a washer. Go through both. Go through the battery cable first, and then the battery. And then we'll do a regular washer, the split washer, and the nut. Okay. And then this. So I think when we put the battery in, before I make it tight, when the battery goes in like this, we're going to want this to bend down and plug into our connector on the robot, something like that. So I think this is kind of what we want. When I tighten these down, I'm going to kind of want this to be pointing up in the air. And this just depends on your robot and how stuff is laid out. Okay, and in order to tighten these, if you have the same battery as I do, they are 8 millimeters. So you'll need an 8 millimeter wrench and socket, or 2 8 millimeter wrenches. If yours are a different size, right, just find the tool that fits, but you'll need 2. And I like to put the wrench on the inside and the socket on the outside and just kind of go until it is tight, and then give it another quarter turn. And you want to make this one pretty tight. So the idea here is you should not be able to move this. This should not rotate by hand after you're done tightening it. If you can still move this, even if it's hard, that's not tight enough, give it another tug. So loose connections early on, like at the battery or the main power, loose connections in those areas are really, really bad for overall robot performance. A loose connection on a motor means that one motor might not work as well as you want. But a loose connection here means your entire robot is going to be potentially suffering from low voltage. So what happens when you have a bad connection is the resistance, the electrical resistance going through that connection goes way up. And when the electrical resistance goes up, it actually takes away the voltage of the battery that you're seeing in the rest of the system. It eats up that voltage. So that means if you have a loose connection here, our 12-volt battery, which is normally around 12.5 volts, could be all the way down to, like, your robot might be seeing 11 or 9 volts, and that is not enough for things to run. So tight connections is very important. Then, after putting this on, it is a rule that we can't have any exposed stuff here. And the easiest way to fix that is to just get some electrical tape and just start going around until everything is covered. And if you have to use a couple of different pieces, sometimes like tearing it, just to get down around the bottom nicely can help. That's pretty good, I think. And then we need a little bit more at the top here. Okay, so that battery is now finished. Let's go ahead and bring the robot over. We're going to drop the battery in where it goes, and I like the wires towards the inside. Okay, and then this battery strap, right, goes down through the hole, through the little slot on the inside. And we can bring it back up and strap the battery in that way. So now our battery isn't going anywhere. And I'm actually going to plug these two connectors together. They only will fit together one way. And the red wires should be matching, and the black wires should be matching. Now, you can plug this in because our power switch should be off, which we'll check first. Find your main breaker here. And on the main breaker, let's see what we can do to hopefully, there we go. From this angle, I think we can see it. So our main breaker is buried down here. On the main breaker, there is a red button that we can press. That turns the robot off. And then to turn it on, you push this yellow tab that says reset. You push that in. Okay, so red is off, and you can see this yellow tab comes out. And when you push it in, then it is on. All right, so make sure you press the red tab first. So now the robot is off. Then we can plug this in, making sure that the red wire, again, is to the red side on the battery and is to the red wire on the other side of this going to our power switch. The black wire should go directly to our power distribution hub. That's step one. Now, step two, we're going to look at all of our connections down here. Make sure that on all of the red terminals, it's a red wire going in, and all of the black terminals, it's a black wire going in. If any of those are backwards, that can be a problem. And our last check before we actually turn the power on is now we're going to look at all of our Spark Maxes. So where we have the connections, these Wago connectors to our Spark Maxes, we have some down here, we have some over here, and then we have one up on the main arm, up on the intake. Make sure all of those are red to red and black to black. Make sure nothing got accidentally flipped. And going to the wire, or to the motors, so mine all look good. And then going to the motors, you can make sure that it is red, white, and black on this one. On our Neo in our 90-degree gearbox, and on our intake, it should be red, white, and black to red, white, and black. Okay, the other motors, it'll be weird if they're plugged in backwards, but it's not going to break anything, so we don't really need to be super concerned about those. All right, that I think is it. So I've done my check. Everything looks like it's plugged in the way that I want it to be plugged in. The next step is I'm going to turn the robot on, and the first time I turn the robot on, I'm just going to turn it on, and then I'm going to turn it off. All right, so we'll flip the switch and just going to turn it off. I saw lights pop up all over the place. So it is working. Actually, it wasn't working. We had to swap the battery out. I think I have a bad battery. So this one works, though. So we're ready to keep moving on. Now, I'm going to turn it back on because I didn't see anything super scary, and the lights were working. And when we turn it back on this time, basically what I'm going to do is I'm going to look to see if there's any smoke or fire. If anything is wired backwards or there's a short circuit somewhere, we should start seeing some smoke or things heating up. So now I'm going to turn it on, and there's a few things you can do. Just kind of look around. All of the devices should have some lights turning on. If anything is not lighting up, that's going to be a problem. You also kind of want to smell. There's like a burning wire smell and a burning electronic smell that you're looking for. Chances are that it's not going to be a problem, but we always like to look for that before we go too far. And I don't see too much of an issue. I don't smell anything. I don't see anything. So I think we're in good shape. So now we're going to look a little bit more carefully. We are looking for lights on the power distribution hub. You'll also get a battery voltage readout. So mine is reading 12, which is actually low battery. Yours should be a little bit higher if it's charged. 12.5 to 12.6 would be a charged up battery. We've got lights along here as well. All of my Spark Maxes are lighting up. My two Victors are lighting up. The roboRio is lighting up. The radio power module is lighting up. The radio itself is lighting up. And the other Spark Max up here that you can't see is lighting up. So that means everything is getting power. I think it's wired correctly. So at this point, I'm going to go ahead and turn it off. I'll throw my battery back on the charger. All right, that is it. We have successfully wired the entire robot. Now, if anything is not working in your robot, the way to kind of troubleshoot it is what light didn't turn on. If this Spark Max's light didn't turn on, then you need to kind of work your way down through those power wires, make sure they're connected on the board, make sure there's a fuse on the board, double check your Wago connectors to make sure they're in all the way. And that's basically it. Whatever didn't light up, you just got to follow the power lines back, look for any issues in them, and that's one of the reasons why we wanted to keep stuff kind of tidy. If you have to cut zip ties, do it and replace them. But yeah, it's looking good on this robot. I will take this battery out and get it charging. Make sure you have charged batteries because the next stuff we're going to do is all going to involve turning on the robot and running it. So that is all we've got for this video. We'll see you in the next one. But before we go, as always, special thanks to Argosy and Everybot.